Hello all, and thank you for joining us today. This is the Digital Audio Protocols webinar, specifically focusing on the digital audio protocols most important to DiGiCo, those that you're going to see most frequently. We're going to try to take a deep dive, understand a lot more about these protocols, also on the console side of things, how to set them up, some limitations, some features and benefits, and we're going to take a deep dive. But before we get started with that, I just wanted to say hello and welcome. Obviously, very odd times for us across the world, but thank you for taking time out of whatever you're doing to join us here today. My name is Ryan Shelton. I'm going to be one of your hosts today. We actually have a team here together to make sure we're taking care of you from all aspects. The first I wanted to introduce is actually Dan Page. He's joining us from just outside of London. Dan Page is our brand ambassador at DiGiCo, and he's been around.
Good evening, everybody.
Hey, Dan. How long have you been with DiGiCo?
12 years.
12 years. Fantastic. And then also running production as well as part of the presentation, Kyle McMahon. Kyle, can you say hi there?
Hello, everybody.
So Kyle normally handles a lot of the U.S. training for DiGiCo. And then we also have in the wings Matt Larson, who is our VP at Group 1, who's the distributor. So if you want to say hi, we're all here and available to take questions, answer those questions, as well as what we have prepared for you today. Speaking of that, we are obviously broadcasting onto YouTube Live. You're here watching us. That's good. A couple of notes. One, there's a comment section. I was looking at it earlier. It looks like a lot of you have found that. This is a great way for you to get your question to us. Dan and Matt are going to be monitoring those comments, obviously for you troublemakers, kick you out of there. But for those of you that have good questions, we'll be taking those and we'll be putting those up and answering those questions as well. Also, if you're new to YouTube or maybe you just have a default setting one way or the other, there's a little gear icon in the bottom right of your window, and that is the quality settings. We are going to be showing you a mixture of video, presentations, screenshots, live video from the console, etc. And the higher you have this quality setting, the sharper that image is going to be, the easier the text is going to be to read, etc. So if you probably a minimum should be about 720, and if your internet supports it, you should probably go up to 1080 for that quality. I will also take the opportunity to mention the fact that we are doing this all at our homes. So we are running off of consumer internet with consumer routers and switches and Wi-Fi in some cases. So if you do lose us for any reason, we have some backups in place, and we are going to get back up and going. So hopefully we won't have any of that today, but just please be patient with us if it does happen. So we'll be able to jump right back on and pick up where we left off. Let's see here. So we talked about who we are, what we're going to cover, questions, comments. Kyle has a link he's going to throw up for you guys. And this is actually a link to a Dropbox folder that we've put together of training documents. If you may know, you can just use your cameras on your smartphone, that camera app, point it at the screen. You don't have to take a picture, but once it's shown on the QR code, it will highlight it and then put a link somewhere on your phone for you to touch and open up that folder. And this is going to take you to a Dropbox folder. A lot of the technical notes that we're going to reference in today's webinar are there. We also have quick start guides. We have a lot of resources for you there as well. So Kyle, leave that up for just a few seconds so you can get out that as well. Dan, I believe, has a link that he can throw into the comments as well for those of you not using the smartphones, QR codes, or if it's just easier. We can do that in a little bit also, so you have a copy of that as well. In addition to the technical notes that we're going to provide you in this link, there are hundreds and hundreds of technical notes that are available from DiGiCo. They can take care of everything from how to replace a panel or a fader driver board on a console to upgrading software, also things like how word clocking works within Opticore. So we have a lot of resources available to you. If there's something that you think you need, questions you may have, reach out to your distributors wherever you're located in the world. Ask them for any DiGiCo has any information that it's usually in the form of a tech note. We publish a lot of those on the website as well, so the website's probably the first place to go to check for those. And then we've kind of collated the ones you may need, dealing with Opticore, dealing with Maddie, and things like that in this training link that we just showed. So I'm Ryan Shelton. I work with Group 1 Limited, who's the distributor in the U.S. for DiGiCo. I'm a national sales manager is actually my title. Previous to that, I worked in both support as well as doing a lot of the education aspect that Kyle has taken on, as well as part of our what we call our DiGiCo Master Series. These are classes we do around the U.S. Kyle is going to take you through that in a little bit, tell you what those are. This is essentially an excerpt from that. We've expanded it a little bit beyond the normal so we could do a deeper dive. And really, with all that, I'm going to turn it over to Kyle. Kyle, where do we start with all this?
Okay, just 1 second. Somebody was asking in the comment section for the training links again. Again, with the training links, QR code, take your phone, point it at it, and it's going to highlight the Dropbox link and it's going to save it. It's going to save it in its current state. So that means if we make changes in the future, you won't have those changes. So after we get done with this presentation and we go to actually publish this into YouTube as a public link, and at that point we're going to try to take that Dropbox link that has some of the training materials inside inside that YouTube link. So, all right, kind of come back to you for just a second, Ryan, before I go to myself.
Sounds good.
All right, so let's see. From there, Ryan, it says we're going to go into session structure. I think we need to go into, we're supposed to go into our slideshow now with you going over the protocol section. Before we go into session structure.
I think you are. I think you're right. So let's do that.
Sorry about that. I did not catch that earlier. All right, coming to you right now.
Sure. So let's start off digging into the protocols you're most commonly going to see in DiGiCo. The two main ones you're going to see are MADI, which is standard on pretty much every device that we make, and then Opticore. That is, for those of you who are not familiar, is a third-party protocol that is developed in, I believe it's just outside of Germany, and blanking on the country it's actually from right now, my apologies. But it's a protocol that is a fiber-based ring transport system. So we're going to start off digging into MADI. We're going to go deeper into Opticore, and then we'll just keep going from there. And then, as Kyle mentioned, we'll take the session structure and build up a session and learn how to configure all this. All right, so I always call this the most boring part of any presentation, but I feel like it's important to go over the details just so you know both the benefits and the limitations of these protocols. First, a little history on MADI. MADI was adopted as an AES standard, AES 10. That was back in 1991. A couple of early digital console manufacturers came together to form that standard. They supported it early on. The important part is they made it an open standard. Obviously, AES had a big part of that, but also what I mean by open standard is not just license-free, is the fact that it could adapt to a lot of different use cases. So originally it was designed for digital recording consoles and digital tape machines to record and push audio back and forth both directions. Obviously we've adapted that, and both the broadcast industry uses it massively, the live audio industry uses it, and actually, oddly enough, less so used in the recording industry these days. But it's a very flexible protocol. And diving into some of the specs, just so you can see this, the first one that we get into is actually how you physically get it from one place to another. Kyle, could you throw up the slides for me there? So if we look at MADI B and C, the spec calls for 56 or 64 channels. When it was originally released, it was 56 channels plus control data. Back in the recording days, that was for arming tracks, disarming tracks, transport controls, etc. Nowadays, like with DiGiCo, we actually use that for gain data. So we can talk back and forth between a console and a rack. We use that same leftover space, so 56 channels plus the control data. You can also change all of our ports to 64 channel ports. This gets rid of the control data but gives you 8 more channels of audio. So same cable. This would be applicable if you were taking audio out of a console to a multi-track recording interface. You don't want all the control or don't need it because maybe those two devices don't talk to each other, and you're just wanting as much audio down that line as possible. So 56 or 64 channels at 48K. Now, when you go to 96K, those numbers cut in half. So if you've ever wondered on a DiGiCo system why we go to 28 channels at 96K, it's because it's normally 56 at 48K and we're halving that into 28s. Now, 56 channels, we have a thing that's called a channel 57. That's where the control data shows up on. It's a lot of fun if you have the time to take one of our racks, plug them into other various manufacturers' consoles, if you have access to those, and you'll actually see a bunch of noise on channel 57. That's our control data as it's being pushed down. All of our consoles know to accept that, to read it, to be able to send back as well. But for the most part, every other device, just about every other device can block. You can put it in a 56 channel mode and it will block out that data as well. Now, the BNC specification is for a 75 ohm coaxial cable. Originally, this was RG59. That's how it's referred to it here in the US and North America. That has been surpassed by RG6, which is basically the same thing, but with thicker insulators and shields. Obviously meant for high definition video, but it's more than adequate to carry MADI BNC 64 channels at 48K. The length is one of the greatest questions in MADI. The actual spec calls for 100 meters. So for our US friends, that's 328 feet. But 100 meters is considered what it is known to work at in most operating conditions. Now, if you have a lot of panel mount connectors, barrel connectors, you're extending that cable, doing things like that, you're effectively reducing the range or the length of that cable. It's all about the voltage drop and the noise that we're getting into the cabling. Usually, with most decent barrel connectors, RG59 or RG6 cabling, the voltage drop is not really an issue. What we usually run into is RF interference or noise that'll actually get into there, and that's usually through things like barrels or panel mount connectors. Now, you can actually go a bit beyond this. If you have a single high-quality cable that's going from device to device, we know in most cases you can push this out to around 125 meters without issue. But once again, that's going to be case-by-case dependent as you get it beyond the 100-meter specification that AES calls for. Now, the other thing is this is a unidirectional interface. Now, unidirectional means it sends in one direction and it receives in the other. For those of you who are super nerds, you'll know that just about every protocol is this way. However, for those of us that are more on the consumer side, we tend to think of an Ethernet cable as magically doing both directions, while in reality, we're doing send and return on various pairs within a Cat5 connector. So this breaks out onto separate connectors, the send and the return. So we can actually go from the console output to the SD rack input. We go from the SD rack output to the console input. So it's out to in, out to in. That way we have our two-way communication between those devices. So you will physically need to swap them, take care of them there. Now, why do we love MADI? I always talk about this because I think it's important to know. If you've studied anything about technology, usually at some point you'll run across something called the technology adoption curve. And the technology adoption curve simply means that as a new product or a new protocol is introduced, there's an adoption curve. So how fast is this technology going to get adopted by the public or by those of you who are using it? And normally it looks something like a bell shape. Now that may be actually extended, it may be more narrow. It depends on how prevalent and how useful and the longevity of that protocol. MADI is such a weird protocol to me in that it doesn't seem to follow the normal technology adoption curve. It just is kind of this line that just keeps going up. Dan, I don't know if you've seen this across where you're at in the UK as well, but it just seems like more and more products are released every year that support MADI.
Yeah, absolutely. It's robust. It's stable. It's widely adopted. It's full bandwidth quality audio. It's just easy to use, easy to understand. Lots of people make products for it. It's great. We love it.
So I have a couple theories on this, and one of the ones that I keep coming back to, obviously you can build a product license free, which it can't be overlooked. So as a manufacturer, you don't have to pay royalties for putting MADI on something. There's a lot of ready-made products that have like MADI drivers that you can add to your product relatively easily. The other thing is it is uncompressed 24-bit PCM audio. So that means there are no codecs. We're not dealing with delay of packet-based audio like you do with audio over IP. The big one, though, is, as Dan mentioned, it is robust. So it works. There's no software that you have to launch to control this or configure this. It is designed originally to be point-to-point. So just take audio from here and get it to here. So you just take a cable, you plug it in. I always joke around, if it doesn't work, go get a cable, another cable, because that first cable is probably bad. It is super easy to work with. Products have been supporting this for a long time, so the protocol is known. And then the last thing on this list is that it actually has incredibly low latency. So this actually, you have to start factoring in things like how long your cable is into just how much latency there is between devices. Now, DiGiCo offers on most products a BNC MADI version of the protocol. Then they also offer a Cat5, or what's commonly referred to as a twisted pair MADI as well. So this was originally designed around Cat5e, so that's the specification we know for it. We also know that Cat6 works brilliantly, so if you're putting cable into a new project, definitely go for a Cat6. We're going to go through a couple of those. First off, it can handle the same number of channels with the same latency, the same bandwidth, all of that. We're really just changing out one format, a BNC cable, for another physical format, an Ethernet cable in this case. So 56 or 64 channels at 48K, 28 or 32 channels at 96K. We still have that channel 57 for control data. Now, getting into the physical cable aspects, you need something that's called shielded twisted pair. Now, I also have seen this represented as shielded or S/FTB, so that shielded foil over twisted pair. So that means that all of the bundles, all of the pairs are actually wrapped in a common shield. Not individual pairs are shielded. So I've seen some cable manufacturers do it both way. Usually individual pairs being shielded is vastly more expensive, and it's actually not necessary in our case. So a Cat6 cable that is S/FTP, once again, depending upon how the manufacturer references that, you need a foil over the entire grouping of pairs in that cable. Now, as far as lengths go, the Cat5, Cat6 is very different. It tends to have a brick wall right at about 100 meters. You can maybe push this a couple more meters either direction, but it is almost entirely a brick wall at that point. So once you go beyond there, it's definitely not guaranteed, not recommended. In fact, when we sell packages like an SD9 and a D2 rack that has a Cat6 cable that comes with it, we sell an upgraded version that goes to 100 meters. So not only are you getting a higher quality over that connection, you are actually doing a better job at rejecting noise, which is, once again, tends to be the enemy in these environments. So not so much are we looking at a drop in voltage, we're looking at that RF interjection into the actual signal. Let's see here. So 100 meters is the length, carries in and out over a single cable. So once again, that's done on the pairs inside of the connector itself. It is still 24-bit PCM audio, still license-free as far as we're using it, and it's going to have the same latency specifications. So that's pretty much it. Dan, or Matt, did we get any questions about MADI at that time? So it's pretty straightforward.
There's a question regarding foil versus braided shielding.
Okay. So on the BNC versions of the Van Dam cables that actually we sell and are, of course, available through other distributors and through other places, the BNC version, we actually do use a foil shield, and that is primarily for, a braided shield, and that is primarily for the tour grade, lay flat, easy to lay down, easy to wind up, tie in a knot if you need to. The foil over version tends to be a little more rigid. It doesn't tend to lay as well, but it does give you 100% coverage, meaning that it's going to do a better job at rejecting RF than a traditional braided would be. Dan, is there anything you want to add to that?
No, I mean, it all comes down to, there's another question about, solid core versus stranded, the bend radius on cables, the way you handle it, if you're rolling it out on, on tours, that sort of specification is going to be important to you. As long as you're meeting our Cat5e or better and sticking to the lengths, then all is good.
Now, the one thing that is not on here that, Kyle, if we're making a note, we should probably add, is when you're dealing with Cat 5e or Cat 6, we recommend, and we actually have a tech note for this, to talk about ferrite suppressors. So you've probably seen these. They're sometimes referred to as chokes, but they're actually ferrite, so a metal that sits right by the connector, like an Ethercon connector on either end of the device. So you're going to have them on both ends of the device. And those also helped to reject noise and to keep it from getting into the line. So once again, the whole name of the game here is to keep the noise, the RF noise, out of the cables. So those chokes are very important, once again, even to install as well as to touring applications.
Ryan.
Yes, sir.
The other thing to mention is when we're dealing with BNC cable, make sure when you're running it, say you run it out to front of house, do not have a coil of 40 or 50 feet of extra BNC cable laying there before it goes into your console. Your 4 and 5 watt two-way radios will leak into the system. It's becoming an induction coil at that point. So make sure, if you've got some extra cable out at front of house, figure eight it. Make sure that you don't keep a ton of extra cable, otherwise you can have those radios will leak into the system.
That is a very good point. Some of our friends watching today, I'm sure, are somewhat RF specialists. I'm sure we have a couple on there that are ham radio nerds as well. And you gentlemen are knowing that you take a coil, a wire, and you coil it up and you create an antenna. And in this case, it's going to be an induction into that cable. So what Kyle's saying there is absolutely valid. Figure eight is going to solve that problem. Or, you can do your best to avoid having a big coil of cable. I usually make a joke in training somewhere about wrapping that big roll of cable around the power distro that has a radio sitting on top of it as well. So you want to avoid that. All right. What's the next slide in there? Okay, so here's a system diagram on just how to simply wire a MADI connection. So first thing to remember is MADI is point to point. MADI does not daisy chain from one device to the next. You can make some of those things work, but it gets very complicated and you need routers to actually handle channels. So for all intents and purposes, take something like a console. In this case, we have a DiGiCo SD10. Connect it to an SD rack. You're actually going to see two SD racks there, and we're going to connect to each of those separately. So we have two MADI ports on an SD10. We are going to connect to the SD racks individually. So MADI port 1 and MADI port number 2. You're going to see that we're running at 48K. I know that because we have one cable going to the rack, one cable coming from the rack, and that is going to carry all the communication, all the control, all the audio, everything we need to control each of those racks. But please notice they are home runs. So they go individually from the racks to the console. All right, on the back of that SD10, this is going to look very similar to a lot of the other consoles that we have across our line. And it really doesn't matter if that's an SD series, an S series, or a Quantum. You're probably going to have some form of MADI connections here. Kyle is zoomed in. We got a red box down kind of that bottom right-hand portion of your screen that's going to show you those MADI connections on the back of the SD10. These physically connect to the engine that processes the audio, and we're going to connect right from the back of this console to the front of that SD rack, which I think, Kyle, we have a few more connection points or animation in that slide, and then he can take us on to.
Yeah, before we go into that, do notice on SD10, SD8, a lot of the consoles do have redundant pairs. So you've got MADI 1A, MADI 2A. So MADI 1A is here, and then you got MADI 2A. There are redundant ports, so this is still MADI 1, but this is a B connection, so it's the redundant port of MADI 1A. So if you're hooking up to two different racks, you're going to plug in on this connection here, and then this connection here. So just make sure if you've got two different racks, if you plug them in here and here, they are not going to show up correctly. So just be mindful of that.
Let's actually take a deeper dive into that real quick, because thank you for bringing that up, Kyle. What is a redundant pair for MADI? Originally, when you're making touring systems, as most of you probably know, you want them to be as robust as possible. And if you want to take that up a notch, you put in a redundancy. So that whether that's a separate set of cables, in this case, this is a separate connection altogether that allows for a redundant connection to the rack. Or in the case of something like the SD7 or the Quantum 7, you actually have a physically separate redundant engine in that case. So what we've done here is we've added another port that is essentially just another set of MADI drivers to give you the same output. So the same thing will be sent out of MADI 1A and MADI 1B. So the outputs are the same. And then what happens on the input side is that whichever one sees clock first from a device like an SD rack, it is going to take from that one. They are not individually addressable. They are designed to be the exact same thing. If you connect a second rack to that MADI 1B, as you did the MADI 1A, it will not see the MADI 1B connection because it is expecting the same thing as a redundant. And if it loses that A, it will move over to the B, which is not how you would want to run separate racks. That's how you would want to run one rack as a redundant. Now, if you're on a new Quantum console, we actually did away with the redundant physical ports, but we gave you twice as many ports, MADI ports that are available, and then we left a software redundancy feature in there as well. So we're going to show you the audio I/O section in a minute. I have a Q338 next to me, and that has software redundant MADI ports. So we can actually configure the ports the same way, or we can break them out into individual MADI ports. So thank you for bringing that up, Kyle. Huge point. We do get a lot of questions.
One more thing to add in there, if I can,
Please
on
do.
the redundant ports. If you're just doing a single rack connection, a single MADI connection from your rack to the console, actually it doesn't matter which you hook up to, 1A or 1B. And actually, from a touring perspective, things get damaged on the road. If the back of your console takes a knock and you've damaged one set of ports, you can just hook up to the B ports and the console works out where the MADI is connected. So, 1A versus 1B, actually on a single MADI connection doesn't matter.
Thank you very much, sir. All right, now while we're here, on the back of this SD10, you're going to actually see two HMA octa-core connectors. So we're going to come back to that in a minute, but I just want you to see where they're located on something like an SD10. Just about every DiGiCo console is going to have some version of these. If you're working as an integrator or in a facility that has a permanently installed console, you're probably going to see a different set of connectors. Those are most likely called SD connectors. We do an optical con version as well. There are certain customers of ours who prefer those connectors. So there's about 3 different versions you're going to see on octa-core. The one you're seeing in this photo is called an HMA or expanded beam connector. All right, Kyle, on from there, there's a Waves audio port. We are not going to take a deep dive into the SoundGrid protocol from Waves. I know Waves is doing a lot of webinars that are available as well, so it's probably good to check one of those out. We may jump into this at another point, but we're not going to focus on that in today's webinar. But this port is a full 64 by 64 channel port at 96K. It's just built into that Waves SoundGrid protocol. You can connect to something like a multi-rack or super rack to run plugin processing. You can also run into SoundGrid Studio or into Super Rack to be able to multi-track record directly off of this port. So it is a full port that's available to you for whatever you need it to do. There's a console network connection. We like pointing these out just so you know what this is and what's available to it. This is just standard control. Like if I was going to connect a wireless access point to fire up an iPad app and to run that connected to the console. That's all this port is going to do. There's going to be no audio. We could take offline software connected to the console, an iPad connected to the console, but that's what's going to happen through this port. If you're using something like Clang or Waves, you're also going to need this port to be able to connect to the computer, Mac or PC that's running the software package to control those applications if you want the integration. And then we have word clock. Now word clock is just clocking, no audio. Also, I point this out, it was most commonly done on the SD9, and I would get a lot of calls on this, that somebody would call me up and say, hey, the MADI input isn't working on this SD9. And just as you do, you go through the dummy checks, and you say, hey, could you just make sure that's not plugged into the word clock? And sure enough, it was. Did that a handful of times, and just enough so that I pointed out to the rest of you. Word clock is a separate physical connection. We're going to go over clocking in a minute, so we'll take a little deeper dive and talk about some of those options, but that is the physical word clock input and output for the console. No audio. All right, Kyle, onto the Matipod. So what we've actually taken is an image of the SD rack Matipod. That is the top center section of the SD rack. This is all the I/O. This is the menu settings. We can connect to here from a USB connection, which we're going to show you in a minute, to a number of different things. But this is the brains of the SD rack itself. And for those of you who have ever had your hands inside of one of these, maybe swapping out optic-core connectors or something like that, you'll know that this entire tray can actually be removed from the SD rack. So there's a very long PC board inside of that rack to which things like an optic-core or daughter board would sit and connect. You would also have, as you see on your front, your menu controls to control the logic that is inside of the SD rack. So the D2 rack is another very popular rack that we have, and this is going to have a very similar menu structure. We're going to go through that in a second. It's not going to have all the same features, but the navigation, the thought process here is exactly the same. Now, the only rack that we make that does not have an on-screen menu is the D rack. So it does have the same type of controls built into it. We just don't have a display for it. So you're going to need to connect to that from your computer to be able to get into those controls. You can also do that directly from something like an SD9. So I could connect a D rack to that SD9 and get to things like the optic-core ID as well as a few other functions on the D rack. All right, so let's dive into the Matipod. So the Matipod you're seeing here has a Mati main connection. So just a second ago, Dan was talking about connecting your rack to your console on either Mati 1A or 1B. This is the connection you would take from the SD rack to do so. So if you can get closely in there and see it, you're going to see there's an in and there's an out. So the out is always at the top, the in's at the bottom, and I can know from my console, I take the output of my console, go to the in on this rack, and out of the rack and go back to the in. That's the Mati main. You're going to see that those are labeled channels 1 through 56, and then there's another diagram at the bottom that says 1 through 28. This is if you're running at 96K. So it cuts down to 28 channels on that first port. We're now showing you the Mati aux connection. So this is an auxiliary or a redundant connection, and that's actually going to let me connect that redundant pair to the SD10 that we showed you earlier on that redundant port. Now, if anything happened to the Mati main, it would switch over to the Mati redundant connection here as well. If you're running at 96K, you need this second connection for channels 29 through 56 on the rack. So you're going to need 4 cables, 2 in, 2 out, going from the console to the SD rack to be able to have all 56 channels at 96K. From there, you're going to have what's called a Mati split. Now, this part is unique to the SD rack, the SD mini rack. Those share the same Matipod and thus the same features from here. So this Mati split can do the same thing. It is just designed to give you a split of whatever is being fed into this rack. So it's a very simple but very powerful feature. So if we take our analog ins, our AS ins, anything that we're feeding into this SD rack, they are going to come out the Mati main, out the Mati aux, and then out the Mati split as well. You'll notice that there's 2 Mati splits, and they are just the output side. So there's actually not an input here. This is just designed purely for a split application. So the process and the thought process here is that we could connect to our main console via the Mati main. We could even connect to a monitor console off of the Mati aux, and that would just be the send only. And then we could take a Mati split and send this to a record, broadcast truck, or somebody that wants a split of those inputs. Now, there is actually a lot of logic and processing that we can put on that Mati split. The first thing is, if you are running your SD rack at 96K, you can use both of those Mati splits to get all the channels out at 96K. There is a menu option to be able to do what's called a system divided by 2 sample rate. So if the rack is running at 96K, we can make those outputs at 48K. This is incredibly useful for those of you who've interfaced with broadcast trucks. So you want to run your touring system or your installation, your room at 96K, but a broadcast truck is only going to ever want to see 48K. So we can, on the rack, convert down to 48K and send that out. And that actually gives us 2 splits at 48K. The other bit of processing that we have there is called gain tracking. For those of you who are used to the DiGiCo ecosystem, you've probably heard that term in reference to consoles, where I can set up a monitor and a front of house console to gain track from each other. So one is going to be in control of the mic pre's, and the other console is going to be gain tracking off of the first. So if the monitor console turns up a mic pre by 6 dB, the front of house console would automatically, in real time, turn down by 6 dB, giving you a net zero change in the level that's coming into the console. We can apply that same processing directly here at the SD rack for those MADI split outputs. So that means if I want to send a constant level output to broadcast or to recording, I can do that through use of this, this gain tracking feature. So that's all controlled via the menu. We're going to show you that in a second. After the MADI split, you're actually going to go on to word clock. So this is if you want to provide an external word clock reference into a rack, or if you want an output from here to something else. So typically, if we want our system to sync to something like video, we would actually take a video reference clock, so something that can spit out a word clock signal, and put it into the SD rack. And that would actually, if it was on an opticore network, would actually reclock the entire network. Kyle's going to go over that with you in just a minute as well. But this is a good way to get word clock in and out of the rack as you need it.
Before we
still
go
there,
on,
guys?
Yes. Can you hear me?
I can. Can you hear me?
Yeah. Okay.
Cool.
Hey, so before we go on from word clock, if you are running opticore and you are bringing a word clock into the system, you're always going to go to the plug it into the device with the lowest network ID. So if it's rack 1.11, you're going to bring your clock into that, and then opticore will automatically look for either the console with the lowest network ID, or if it's plugged into a rack, the rack with the lowest network ID, and every device on the network will see that same clock.
All right, as we're going to reference in a minute and show you this, but the Technical Note 300 will cover that in detail. Our lovely Tony Crockett from the UK put that together for us, and so it goes into great detail on how to configure your opticore systems for clocking. Now, speaking of opticore, this is an option on the SD racks. The vast majority of racks, SD racks in North America, are configured with opticore. Then from there, there's a handful that do MADI only. I know it varies greatly across the world, but just so you know, that is an option. So opticore does not have to come on the rack, but it is part of that a typical opticore system, a typical console package that we're going to see in North America at least. So these are the opticore HMA or expanded beam. It's a military grade or mil-spec connector, very rugged. Company we use called FiberCo that manufactures these fantastic thousands and thousands of tens of thousands of connections that these things are rated for. Super easy to clean, very robust, as you would imagine. Also with that, expensive. So, you know, you get what you pay for in that. I will show you some ST wiring diagrams in a minute, but if this did have ST connectors on this SD rack, you would actually have 4 individual connections on there, because an HMA connector actually has 2 strands of fiber and 2 lenses per connector. So you're actually doing a send and return per that. What you see is like labeled A on that SD rack MADI pod. And if that were broken out into ST connectors, you would have individual ST connectors in and out for A. All right, and then the last thing to mention on this rack is actually the USB connection. So it's important to note that this is control only. We can't just plug it in and record straight to our laptop, which would actually be pretty cool. But there is a, I am convinced, permanently in beta software from DiGiCo that's called DiGiCo Control. That is available for Mac and PC. Don't think it's supported in the latest version of Catalina for Mac because it is a 32-bit app. So once again, it'll stay in beta. But anyway, this app lets me directly control the mic pre's on the SD rack. So I can actually get in there, control. I can set things like opticore IDs. I can set things like sample rate. I can turn on and off the internal word clock that's inside of the rack itself. So if I'm using this in a standalone application, I can do that. Now, there is another option in the menu structure to change that USB from controlling the rack to controlling the opticore card. If you've been a DiGiCo user for a long time and you were version, remember, I think it was version 6.8.1. Does that sound right, Dan? When we actually had to do the version 5 update to the opticore cards,
that sounds
you
about
would
right,
have. Yeah, you would have had to take your like a Windows computer of some kind, a laptop or a PC, and take the OptiCore folder from your console, put it on the laptop, and then push that update to the OptiCore module itself. And that would have happened through that USB connection. I have fond memories. I don't know if Brandon is watching from Gateway, but going over to Gateway Church, where they have a lot of consoles. They have a lot of SD7s, which requires this done to each engine, and a lot of SD racks. And we spent all day going through and updating these OptiCore firmwares on all the devices. It's not something we commonly change. Most of the time we do it on the back end in software, but sometimes you do need it to happen within the firmware. I believe one of the best things to come out of that firmware update was the ability for us to do more than just 56 total virtual console sends, that we could actually do 56 from each of the consoles that were on the network, providing there's room for it. All right, that's pretty much it to do with the MattyPod. This right here is a manual that's available for the SD rack. That's available on the website. Kyle, is this one available in that folder link that you sent out earlier?
Yeah, and the Dropbox link that I sent earlier, it is inside that. There's a couple screenshots of this one and the following one. We'll go back to this one. Also, by the way, I've seen in the comments that people are saying my mic is still a little bit low. It looks like going to Skype, it's compensating for that, so that's why they're hearing at a normal level. But I'm actually driving this from my computer, so let me know, guys, if that level is better. I have turned up several dB since we started, so let me know if that does get better. All right, back to you, Ryan.
Cool. So as Kyle mentioned, this is going to be in that training links folder that we sent you guys, and that you got the QR code for at the beginning. We'll show you that again at the end. I think Dan sent out the link as well. But this is the manual that'll show you the menu structure for the SD rack. As mentioned before, the D2 menu is a derivative of this, so you're going to have a lot of the same functions that you would see in a D2 rack as you would in an SD rack. Now, the way this works, as you move up and down on the buttons next to your SD rack, Kyle, can you go back to the MattyPod for a second? I know this is going to cause some extra animations, but if you see with that little display, there's actually a left and a right arrow key above the display, and there's an up and a down arrow key to move through those menu options. So, Kyle, if you can get us back to the menu now.
Okay, on my way.
Thanks, bud. All right, so here, if you move vertically through these rows, that's using the up and down arrow key to move you through. So you're going to start with things like do you want to default the rack? I think the green, single green square in the middle of this page that shows things like receive is Matty main, sync is Matty main, showing it's at 48K, and it's got 4 letters at the bottom, WMXO. That is your main screen that you're gonna, when you unlock the SD rack, that's what you're going to be presented with. So you can actually go up a few more menu items to things like defaulting a rack, what the rack type is, the version, software, firmware versions for the different cards and things that are in there as well. Or you can go down. So the first thing you go down to is the OptiCore ID. We're going to jump into OptiCore in a minute, but just know that everything needs a separate ID that's going to be on the network. This is where you change that. Down from there, you have fiber speed. If you are running a console like an SD10 and you're connecting to older DigiRacks, those are going to run OptiCore version 2.2.0, and you're going to need to be running at 1G speeds to connect to those. That's running older firmware. That's a lower speed. If you're connecting with SD racks, you're going to need to be at 2G speeds, and that's OptiCore version 2.2.1. Now, you cannot mix these two, so it's important to know that, which is why they physically transmit at different speeds across that network. Down from there, you have that USB selection that we were talking about. That's USB selecting either the rack control or OptiCore. Down from there, you have set sync. Now, by default, your rack should come set to sync source as auto. And what that means is it's going to start going from the leftmost connection point that's listed. Those 4 letters I mentioned earlier at the bottom, WMXO, is the typical order. Auto means it's going to look through all of those, and whatever is leftmost, so the W would be the first one, that is word clock, that is the default, and it means word clock is going to override all of the other clocking sources. So auto is just going to look through what it has, whatever the leftmost is, it's going to grab. Now, walking through these a little bit, you can actually change this order. So instead of dealing word clock, MADI main, MADI aux, and then opti-core, you can change this around. So maybe you want your word clock as a backup, but you want MADI as your main. You could do something like that as well. Pretty much, though, it's most common to leave it as auto, let it sort itself, and then keep in mind that you're probably only going to run opti-core or MADI. You are not going to be running both. If you do, typically the rack will take over and clock off of, put all the output and the control and everything off of that MADI connection. It's going to look for it as far as a sync and as far as routing is concerned. So you change that down below as well in what they call the sync order. That's the bottom row that we're looking at here. I'm not going to read all these for you. I know you can do some reading. Kyle, if you could just jump onto the next slide so they can see the rest of the hierarchy of the menu. You're going to see options in here, as we mentioned before, about MADI split main and MADI split aux. So that's MADI SM, split main, and MADI split aux, SX, on, just to abbreviate those so they fit on the little display. And then we can actually change whether those are running at the system sample rate, system divided by 2. So if the SD rack's at 96K, we'd be at 48K, and you're going to have a couple other options to configure those as well. Things like rack type, so do you want it to show up like an SD rack? So meaning I'm sharing it with another DiGiCo type console. Do I want to show up as just MADI, so 56 channel MADI or 64 channel format MADI as well? So all those options are baked in there. You're also going to have things like the gain tracking that you can turn on for those ports as well. But all that's going to be handled through the menu, and a lot of that functionality can actually be done directly from the console when you're connected to it.
Hey, Ryan.
Sir.
There's a quick question I want to answer about syncing and the optical loop. Someone says, can I sync optical from an external word clock connected to an SD rack? And it sort of goes back to what Carl was saying earlier. You know, and that auto order you have, that's word clock, MADI main, MADI aux, optical. If you clock to optics and you insert the word clock, assuming it's in auto mode, adding the word clock to the rack will override the optical clock that's on the rack. And actually, if you're applying that word clock to a rack in the system, that rack actually like puts its hand up and goes, I'm now in charge of clocking, and it then propagates clock around the loop from there. So you can override optic loop clocking from its default, you know, engine, lowest ID engine taking the clock, and using that as a master round by putting word clock into a rack. But unless you have a really good reason to start messing with the clocking scenarios and the structure of that, my suggestion is you don't. You let the engine and the way, you know, the self-negotiating clock is designed to just take care of it. And you know, it's synchronous audio across the entire system. So unless you have a very good reason to start doing it, my suggestion is you don't.
Since we're here, one of the most common scenarios we see is like a house of worship or a performance venue, something that has video, like, once again, like a video broadcast suite, and then their audio system. And what you typically want is if you have like a MADI connection directly into a video router, or you have connections between these two that are digital, and you want them to stay together, so they need a common clocking reference. Typically what we do is we take a high quality video clock that's going to generate a word clock output in addition to all the video sync protocols it needs, and you're going to have that run into that first SD rack, so the lowest SD rack ID on the network. The beautiful part of this is if you leave everything in auto, what will happen is when video is up and running, our entire system is going to clock off of that. And if video shuts down for whatever reason, powers down, then our system will continue to auto-negotiate its own clock. So it actually won't, it doesn't stop, it doesn't freak out. It's just like, okay, my external word clock is gone. As Dan mentioned, that SD rack that raised its hand and said, hey, I'm clocking master now, will just go away, and it will continue on just like nothing changed, which is a really seamless way to move back and forth in installations like that.
Yeah, there is no audio quality performance advantage by applying clock to everything. You know, it's not going to sound any better, unlike, you know, old studio days 20 years ago when you could improve the sound. And ultimately, all you're going to do is complicate things. So, you know, don't think you're gonna make it all sound different or better by putting some clock in, because you're not.
Thanks, Dan. All right. I was, going to do that a little more politically, but, that works great too. Anyway, okay. Not going to happen. Not going to happen. Okay, so Kyle, what's our next slide that we got on there as well? I can't remember.
Before we leave this slide, let's talk about the split option from the hierarchy for the output cards.
Okay, so this is actually kind of cool, and we talked about MADI split. So if we want to actually take what's coming into the input side of this rack, we can have that not only come out MADI main, MADI aux, and MADI split. We actually have a software option to be able to take whatever's coming in card 1 and have it mirrored to come out of output card number 1, or would actually be the 8th slot on the rack. So the way that works is if I plug something into, let's say, a mic pre-card, slot number 1 and socket number 1, so the first input on this rack, I could have the same thing that's coming into the rack come out of the rack in slot number 8, socket number 1. This is just a 1-to-1. So whatever I do to this first one, it's going to come out of the second one. And the beautiful part of that is if somebody needs a split to an analog setup, so you're running everything into your rack, you don't want to run through some sort of splitter. Maybe the splitter they have is not a fantastic quality, but they still want an analog feed from your rack. You can use your available analog output cards on your rack to split whatever's coming into the rack to the physical outputs on the same rack, which can be really handy in certain types of situations. I believe we have a couple of performing arts centers who are taking advantage of this. They bring in analog consoles or something like that, or if they have an existing console in the venue that they want to tie into from analog, they can use this format as well. So. All right, now physically talking about connections again, we have an ST12 this time, and you're going to see there's a cluster of 4 BNC connectors, and we have a red and a blue cable going from the console to the BNC connections on the D2 rack. So this time we are connecting at 48 or 96K. This page is 48K. So we're having 2 cables, 1 send, 1 return from the console to the rack. That's going to give us 48 channels out of this D2 rack. If we run an SD rack, that would be 56 channels out of it at 48K. It's going to give us half that at 96K. And remember, we're dealing a max 100 meter distance between devices. And once again, 75 ohm RG59 or RG6 cabling between those. Next, we're actually looking at 96K. So leave the red and the blue cables in place and add the yellow and the green. So we're going to have a total of 4 connectors, 4 cables that are coming from this SD12 to the single D2 rack, so we can get all 48 channels at 96K. Same type of cabling, all that good stuff I just mentioned before. Just want you guys to see that in detail.
Ryan.
Sir?
Yeah, so I wanted to bring up about the RG59, RG6 cable. We have heard from people in support before. Our guys have seen that. Pay attention to your RG6 cables if you're using. RG59 is going to be, the typical standard. Usually all the connections are the same as far as your BNC connection. We support guys have said they have seen RG6 cables where the actual pin diameter is slightly larger. And so they have, if you take that larger diameter and you plug it in, it will mate that one time, but then it's going to expand
when you come back with an RG59 after the fact, now the center conductor is too large and it's going to be an intermittent connection inside of there at best. That's a very good point.
Yeah, so just heads up on that. RG59 is what we recommend. RG6 can be used in a pinch, just pay attention. Most of the RG6 are going to be fine, but they have ran into some issues. So.
And I do believe somebody can probably correct me on this because it's YouTube and there's a comment section, so correct me if I'm wrong on this, but I do think there actually are RG59 connectors for RG6 cables as well. I believe that is something that you can source just to confirm you have the right pin diameter there. All right, thanks, Kyle. What are we on to next? All right, so we're going to talk about, just like we mentioned before, actually sharing 2 consoles, sharing 1 rack. So in this case, we have an SD12, and then we have an SD9, and then we're going to share a single D2 rack between them just using MADI. So here we have a D2 rack, and I'm actually, in this case, connecting to the monitor console is the SD12. And I'll tell you why we do that as well, but you're going to see there's 2 cables going from the SD12 at the bottom to the D2 rack, the input rack, so it's doing send and return. You'll notice from the D2 rack to the SD9, there's a single cable going from the output, so this would be the MADI aux on the D2 rack, going to the MADI in on the SD9. Now, the way this works is that both consoles are going to see exactly the same channels in exactly the same order, assuming they're set at the same sample rate. So we're going to see those same things. They're all going to see gains, so the mic pre's move at exactly the same time on exactly the same channels. The difference here is that the SD12 has the return connection to the rack. So that one is actually going to control the D2 rack. It is not only going to control things like routing and sync, it is going to have the physical outputs out of that rack also. It's going to control the mic pre's. All of that is going to happen based on the connection from the SD12 to the D2 rack. If we wanted the SD9 to be in control, we would remove the connection going from the SD12 to the D2 rack, and we would instead put that from the SD9 to the D2 rack. So we would move that around if we wanted the other console to be in control. With MADI, only one console gets to be routing master, sync master, and with that comes things like mic pre-control, etc. So only one console gets to do that with MADI. One of the many benefits of OptiCore is the ability to be able to split up things like multiple consoles controlling mic pre's, multiple consoles can share, well, divvy up the output cards between them. So now, what Kyle has shown us here next to each of these consoles is we actually have a couple of menus from the respective consoles. So you're going to see that SD12, we have a network page, and you're actually going to see on that network page, it is set to audio master. That means it is pushing controls to the rack for things like mic pre, phantom, etc. Any type of, like if there's a pad on that particular rack or something like that on that input, it'll be able to control that. Below the network page, you're actually going to see the audio clocking, or what we call our audio sync page, and you're going to see that it is set to master. So that SD12 is the clock master. It is generating clock, which is traveling to the D2 rack from that blue cable. It is being passed on to the SD9. So we need to set that SD9. We need to turn off Audio Master, which is going to tell the software you do not have control over the mic pre's via MADI. And then you're going to see on that bottom right window that it is looking at the clock off of MADI 3. And the SD9 is clocking off of the D2 rack in this case. So normally, the rack is just going to follow whatever MADI input comes into it. The clocking is going to follow with that. But in this case, it's doing that, but it's also passing on that clock back to that SD9, so the SD9 can follow it. If we did not switch the SD9 and it left it on master as it would be in a default session, then we would have two clocks that are fighting each other. So we would end up with things like clicks and pops. You would have slips in the audio. You would have audible artifacts to that setup. So if you forget that little step, you'll hear it and you'll be like, is it a bad cable or did I forget to change the audio sync? And typically audio sync is the most common issue there. So your main console, the one that's controlling the outputs, the mic pre's, etc., set that one to master. The one that is getting the split from the rack, that one needs to be set to follow clocking from that rack. Anything to add here, gentlemen?
Before we go on, there have been some people asking about slides and if they are able to get access to this. We're not going to share the whole presentation because it's several hundred megabytes. But in this case, we are sharing a PDF version of this. So what we're going through as far as the keynote portion of this presentation is in that same Dropbox folder that we shared, and it's under the Quick Start Guides.
Fantastic. Okay, cool. So let's see here. Matt's, never mind. We're good there. Audio I/O. So what we're doing here is the same type of setup, but this time we're doing it with SD9s using Cat5e or Cat6 cabling between them. Now, one of the things you cannot do with a Cat6 cable is you cannot choose to connect half of the cable. We can do that with a BNC. We can say just the send, just the return, or both. With a Cat5, since it does send and return, we have to connect the entire thing. Excuse me. Once again, the SD9 uses these boxes called a little red box. A little LRB is the analogy we're using here for it, or the abbreviation for it. And that is The little red box is designed to basically do just what I was saying, to connect a portion of the cable without connecting the full thing. It lets us take something like a D-rack, which has a single Cat5e, Cat6 connection, and share that single rack between two consoles. But we need to choose who's going to have full connection to the rack. So in this case, that SD9 at the bottom, that SD9 is full gain control. It is audio sync master, just like the slide we had before. And it is going into full connect on the little red box, which is pushing clock to the D rack and gain control and routing, etc. So audio outputs. That word clock, after hitting the rack, is returning back to the little red box and being passed onto the receive only SD9, which is the SD9 in the top right portion of your screen. And that is going to be set to external sync, meaning I'm going to clock off of my Cat5.1 MADI source. You'll see in that audio sync window that Kyle has for you down in the bottom right, that is actually taking clock off of the rack, which is what we want in this case, just like we did before. So just remember, it's exactly the same thing when you're dealing with MADI Cat5e or Cat6 as you are dealing with MADI B and C. The difference there is that we just can't connect half of the connection. So if we want to split or share, we need something like the little red box to be able to do that function. All right. Kyle, what are we on to next? All right, so here we have two SD12s. And we're actually connecting them just like we were before. This is going to look very similar to that first slide. And you're going to have the SD12 at the bottom have a send and return to the D2 rack, and then a split off of here going to the second one. And once again, we're just showing you that the bottom one needs to be the audio sync master. The one on the upper right needs to be receiving from the rack for this to work. And only one cable. All right. Take a breath now. We've made it through MADI, and we can actually move on to Opticore. Now, Opticore has been around for a while, been in development, gone through numerous versions, firmware versions, software and control versions, obviously added a lot of features. The core, the backbone of it, since we have seen it, has been rather unchanged, meaning that the way the network works is essentially the same. And a brief overview, you're going to have a bunch of different devices that are all connected together optically, so via optical cables. These can be whatever type of connector you want, but we need the connection between all of them. It's going to be connected in a ring, so a ring topology. So we're going to show you this in more depth. Everything gets an ID, so consoles get an ID, SD racks, mini racks, nano racks, D racks, orange boxes, they all get an ID. And that ID is different from every other one, and that lets us just see those devices and to auto-discover those devices on the network. The cool part about the ring topology, as we're going to get to in a second, is it can be configured in either a redundant loop or daisy chain configurations. You have a lot of flexibility with how this is deployed. So, big picture, 504 audio channels at 48 or 96K. The big important thing here, it is provisioned around 96K. So you do not lose channels when you go to 96K. And that is one of the biggest reasons to use Opticore, is if my system is running at 96K and I have a lot of I/O, it's very economical, it's a very easy way, very simple way, cabling wise, to get everything between those devices. So 504 channels at 48 or 96K, and that is per loop. On consoles like the SD12, the Quantum 3, the Quantum 5, the Quantum 7, these all have options for a second Opticore loop. So you can have another set of 504 channels if 504 just is not enough for you for some reason. All right, now onto the topology. It is a ring-based network, as I mentioned before. That means we can connect it in daisy chain. I can take one cable, which has two conductors or two strands of fibers, and I can go from an SD rack to a console, and I'll have full control, and I'm done. More commonly, though, we are going to close that loop, and we're going to go from the SD rack back to the console, and we are going to create a big loop. We're going to have diagrams for you in a second. Now, standard fiber, as we typically, once again, sell it in North America, is going to be multi-mode, and this is 50 micron-125. That is good for about 350 meters between each device. That is not the entire loop, that is device to device. Once again, for our American friends, it's just shy of 1,000 feet is the distance there, and that is between device to device. As we were talking about, the more panel mount connectors, barrels, things like that you put into a BNC cable can degrade that signal over the effective length of the cable. It happens obviously very different with fiber, but it still happens. So we're not looking obviously for a voltage loss, we're looking for a light loss, and we usually measure that in dB. These cables, that 350 meter effective length would be assuming that you're basically taking a cable and going directly from one device to the other. Though I do know you can stretch that a little bit if needed as well. And then depending upon how many connectors you have, if you had let's see here, 5 meter jumpers, and you connected, 300 or 30 jumpers together, you're going to be dealing with enough loss that effective distance won't make sense in your setup. So just keep that in mind as you're laying out your systems. So, and this was once again just between one device and the next. That is not the loop as a whole. So that is multi-mode. We do have an option for single mode. Typically we see these are our broadcasting friends. So whether that's sporting arenas, complexes, people who are just heavy into video, maybe they pulled single mode throughout the facility. We have a couple of arenas that are this way, some churches that are this way. They pulled single mode fiber, they have it. We do an option for that as well. So this is 9 micron is the typical one there, though we can, you can special order to match whatever wavelength that you need to on that as well. Now, regardless of the type of fiber, multi-mode or single mode that you're using, the connector can actually change out based on your needs. If you're in a touring application, that HMA or expanded beam connector is incredibly rugged, robust, simple to make the connection once you've done it a time or two, and it is just a beautiful connector to work with. We have people that have had them for well over a decade now, and those cables and connectors are still going strong. The downsides to them, obviously, with something that well made, there's a cost. There's also a field serviceability aspect to them. If somebody runs over and cuts through your HMA cable, we need to send that back to a factory service center to be able to find where that connection is. Typically, they cut the cable at that point and add on 2 more connectors. And so you have 2 shorter cables out of your single longer one. So there really is not a lot we can do on repairing those. They can repair the connectors and stuff like that, or put new connectors on them if needed, but it is not something you're going to be doing in the field. The next most common you're going to see is ST connectors. These look actually like mini BNC connectors, but they do have the fiber in the center strand of them. And those are very common on installs. So some place that a console is not moving. We'll also see them in broadcast a lot. Typically your higher end broadcasting what am I thinking? Networks is actually the word I was looking for. Those, when they deploy a truck to something like a sporting event, which we don't have anymore, hopefully soon, but when we have those again, they're going to have a fiber technician with them. That fiber technician is metering those connections, cleaning those connections. They're on site. So while we don't recommend somebody to tour around in a portable situation with ST fibers, if you weren't, an optical technician, a fiber tech, maybe that's worth it to you, but they're just not rugged. They're not designed to be definitely for permanent installs. Now, somewhere in the middle is a Neutrik optical con connector. This takes those relatively fragile LC connections like you would have inside of a device, or you've probably seen on network switches and equipment, and it puts a rugged housing around those connections. Now, it has a simple barn door structure that is sealed. It's designed to keep out a little bit of dust, definitely dirt, debris, all the big stuff in there. It's a good quality cable, but for us, it's somewhere in the middle of that spectrum. It is not as rugged as an HMA connector. When we see optical con cables failing, it is typically due to strain relief. So you're not putting a service loop on that cable. People are pulling on those cables, or you have a heavy loom of cables pulling on that optical con connection, and that is typically where we see them fail. But we also would highly recommend them for like a portable monitor application in a performing arts center or in a house of worship. In a semi-rugged application, they're going to do okay in that application. It really depends on the level of ruggedness you need out of that connector. There's plenty of jokes about handing an HMA connector over to a stagehand and that cable actually surviving that encounter. So anyway, moving on from there, so once you've chosen your connector, you've chosen your mode of fiber, whether that's single mode or multi-mode, we're back to the same kind of benefits of MADI. So it's 24-bit PCM audio, meaning it is not packet-based. We do not have to wait for IP-based communication between these two. There's not the kind of a network inherent delay that you would have as a packet-based network. And Opticore is nice enough to have measured it for us, and it's 41.6 microseconds, which is pretty fast. So there's very, very low latency across the Opticore network, which is awesome. Now, you'll see at the bottom of this page, we actually refer to Technical Note 101. So Technical Note 101 is in that folder as well, and it actually has a lot of information on calculating losses, what you can expect in a typical connector, kind of recommendations on how many connectors you can put together in an application. If you are doing an installation, it is highly recommended that you have some sort of optical meter. Our support team, the UK support team, can recommend a brand to you as well, but you can measure the output directly off the console, connect the cable, measure it off the other end, see how much loss you're getting through those. A couple of installs I've had the pleasure of going to work with, we've actually found bad cables, brand new prepackaged cables from manufacturers that had 9, 12, 15 dB losses directly out of the box. So brand new or packaged, brand new cables. We were wondering why nothing was working. We metered it and come to find out it was just a bad patch cable. So something to look out for as well. Yes, Kyle?
We had a question from Chris Carnell. He says, is there a hardware difference on the console between multi-mode and single mode?
It's a great question. So if you looked at the inside of a DiGiCo console, you would have what's called the engine. That is the audio engine that processes the audio. And sitting on that is going to be a separate PC board. That's a daughter board. And that is going to be the Opticore PC board. Within that, you have SFP cages. If you're not familiar with optics, it's something that's called, I think it's small form factor pluggable was the original name behind that. And these are removable transceivers. It's got an in and an out on the actual SFP module. These are going to change from single mode to multi-mode. They are different wavelengths of light. So diving into a little bit more depth, a multi-mode is actually more like an infrared. So it's a broad spectrum of light. It is not a single wavelength. It's a broad spectrum. It is typically focused around 850 nanometers, which is what the wavelength of what we use for multi-mode, but it is a wide spectrum. And then single mode is the opposite of that. It is a single wavelength of light, typically done with a laser. I think they have other ways of doing this now with some diodes, but you're basically picking one wavelength of light. In our standard case, it's 1310 nanometers, and those are just, we swap out the SFPs and we swap out the cables, what we call jumpers, that go from that SFP to the chassis of the console.
I would say just there are 4 SFPs inside a rack. Make sure you swap them all, because you can end up in a situation where you could have half of your rack being multi-mode and half single mode, and you wouldn't be able to tell from the outside which was which unless you'd labeled it properly, and it's just a dangerous situation to be in. So if you're going to swap between multi-mode and single mode, do your whole system.
Now, one of the cool things about a lot of you that are on this webinar right now is if you're a heavy into DiGiCo user, you've probably run across some really unique situations where you've needed certain things out of DiGiCo. So one of those that I got to be at least talking with one of the production companies who help support this is you can actually mix and match single mode and multi-mode. The danger here is exactly what Dan talked about. If you swap out SFPs in part of your ring to do like a longer run, maybe make it out to where a broadcast truck is, etc., you don't have to convert the entire ring. You just have to convert both sides of both devices that other third device that is single mode is connected to. Please mark them, please swap them back when you get back, because they are absolutely not compatible and will not work when you get back, and inevitably you'll be in a rush. That rack will go back out, and you'll be on site trying to troubleshoot that, which we've also done a handful of times for people as well. Dan, I know you have too. Yeah. So anyway, so yeah, the UK has been putting out a lot of the single mode ST connectors with little yellow washers around things like the orange box, the DMI cards, stuff like this. It's a really helpful way to notate what's going on. So if you see yellow washers around things like an Opto DMI card or something like that, those are single mode. All right, Kyle, could you bring back up our slide for us? Cool. So getting a little bit deeper into OptiCore, there is some firmware restrictions we put on the loop, kind of assumptions that we made, and this is primarily to help you set up things faster in the system. So rather than being infinitely configurable, we actually fixed a lot of these things for you. First off, we have 24 IDs that you can have on a single loop. So the first 10 IDs are actually related to consoles. So you're actually going to see here that we're limited to 5 consoles per single loop, plus a redundant engine per console. So that means you can actually have 2 OptiCore IDs per console, so the primary and the redundant. So that accounts for 10 IDs. The next line down, you see that there are 14 IDs that are available for things like SD racks, mini racks, nano racks, D racks, orange boxes, and then at the very bottom, there's some OptiCore hardware straight from OptiCore that is compatible and supported via our software, and you can add those into the loop as well. But keep in mind, you have 14 rack IDs that are available for those devices. Once again, that is per loop. So if you have a second loop, you need more stuff. I know who you are out there as well, because we've talked to a lot of you guys. Then if you're using up more than one, you need to add the second loop just for enough channels or devices in there as well. Now, as mentioned before, 504 channels, that is inputs and outputs per optic loop. Both count towards your total. So if I was taking 256 inputs into my console, I would only be able to take 248 outs out of that same console to fully saturate or fully use up an entire OptiCore loop. Does that make sense? Cool. Did I do my math right on that? I think I carry that. All right, now, fantastic. Thanks, Kyle. I just have this YouTube video around forever, everybody making fun of my math. The next one down is you actually see we have something called Virtual Console Sense. So this is an amazing feature that they added initially on just for the basic stuff. Like I want to send a talkback mic from front of house to monitors. I want them to be able to hear me. I want to send, back and forth the other direction, maybe some playback music from front of house. The monitor engineers is actually doing the mix for the lighting guy. We're pushing that through the console for however you want to set that up. That was the initial intention behind this. However, you, our users, have taken this to a whole nother level. And this, we've actually changed the firmware to accommodate for this. Assuming you have channels available on the loop, you can do 56 channels of virtual sends per console. Now, what can I do with this, and why would I want that? There was an amazing show of performance in several years ago in New York. I'm not going to mention who it was. I've mentioned this in previous training classes before, but the artist went all out. I think it was 6 or 7 nights, entirely sold out, as you would imagine, and they just kind of spared no expense, as it was said. So they had an SD7 at front of house, an SD10 at monitors for the artist, an SD10 at monitors for the orchestra and band, and then they had an SD10 in a separate room that was doing live, real-time mixing of the orchestra. And that engineer would take all those orchestra inputs, mix them down to 28 stereo groups, and put those 28 stereo groups onto the fiber sends, those what we call OptiCore sends. So those pre-mixed orchestra was available to all of the other consoles. So if the monitor engineer that was mixing the artist just simply wanted to pull up the violins, he did not have to individually go through each violin microphone, EQ them, high pass them, group them together, work through that. He could just pull up the individual violin section as pre-mixed from the other engineer. That was in kind of like a portable studio that they set up for him. So that is an awesome application. So you can use it as anything as basic from I want to take a talkback mic from front of house to monitors, or I want to send video elements that I'm taking in locally. However you want to handle it, this just provides you with with additional flexibility.
We actually had sorry to interrupt, we had a great application of it where one engineer was sending the oscillator across the loop to all the other consoles and using that to duck the main artist's vocal on every other console, so you could have private conversations with the artist without anyone else listening in, without telling people to mute it, whatever. So, as Ryan says, there are a whole bunch of applications, and we've done similar things with, multiple SD7s, orchestra premix, putting stems out. We did a big George Michael gig with 5 SD7s doing exactly that. So, yeah, it's as we'll come to, it can be a little bit tricky to set up, but once you've got it up and running, it's a great application.
Yeah, and the key here is just flexibility for you. So we've just tried to put in extra room into the format, into the structure, so that you can do what you need to for your setup. All right, continuing on down to the next one, just reiterating 48 or 96K. It's supporting all of those, everything we just mentioned before, all 24 devices, 24 IDs, and it can do all that with 504 channels. Included in that 504 would be the 56 channels a virtual console sends, and it can do that at 48 or 96K. Now, the way this all works and why it's so easy to set up is that all of the surfaces, so all of the consoles, Q3 or an SD10, they can see all of the inputs from all of the racks. So they can control a mic pre, or they can be receiving what that mic pre is doing, but every console is going to see all the inputs from every rack on the system. You don't have to configure anything. That's the way it shows up. What you actually configure is who's going to control the rack, which Kyle is going to walk us through later. Outputs can be assigned to any console on a card-by-card basis. Kyle, if you can go back to my camera view, you're actually going to see on my right on the side of my screen here, I actually have some output cards into this rack. Now I could take card number 1, that could go to front of house, card number 2 to monitors, card number 3 to monitors as well, because of course monitor engineers are special and they need more outputs. Now, here, that's just an example of it, but those can be individually assigned. Kyle has some more kind of flowcharts, diagrams, software to show you how this works in depth. Last thing on this page is that we can natively support from the consoles Opticore a DD32, that's an AES I/O box, DD2 or DD4, that is a MADI, BNC, or optical. The 2 is the BNC, the 4 is the optical I/O box. An S6R, which is a 16 I/O box, 16 in or out, or 8x8, AES, analog, you kind of choose, just way to drop it on. I believe it supports intercom now as well, so there's a comms version of this, so you can put your comms on the fiber loop if you wanted to. A PG16, anything with a PG in front of it, is actually the ClearComm version of the Opticore box. So a PG32 is the AES version, that's from ClearComm. The PG2 is the BNC version of the MADI I/O box. And then the last thing to note is there's a really cool box called a Broman Route 66. And they've also marketed this as an Opticore auto router. So you may see the two interchangeable terms. What that basically does is, instead of just having a loop where you go from device to device to device to device to device back to the other devices, this lets you connect like front of house and a front of house SD rack to the Route 66. And then you go to 2 SD racks that may be for the stage. Then you go to the monitor setup, and then you go to maybe a couple of single mode SFPs get put in there, and you connect to a broadcast console or to something that is far away, maybe another venue entirely. And this creates what is essentially a star, but it is very importantly still a loop. So it is sending in and out, and it's just auto-connecting that loop for you, which is pretty cool. Definitely a box to check out. If you need more resources on that, please let us know. We can get you in touch not only with the Opticore team, we could probably help you with most of that as well. All right, I need to catch my breath. And now we have some system examples. This is an award show that we made up in PowerPoint because copy and paste is cheap. So here we have a SD7, or a Quantum 7. Of course, it's a Quantum because, once again, this is PowerPoint. So it's a Quantum 7 that is doing the front of house for music. So it's doing the music mix for those that are in the room. So we're going to give that IDs 1 and 2. The reason it's got 2 IDs is the Quantum 7 has 2 audio engines, 2 consoles in one. So it's going to have a main and a redundant. The main is always an odd number. So that is ID 1, and that redundant is ID 2, the even number. You're going to see there's a front of house production. They're the ones turning up the microphone for the celebrities to accept their award, and then turn it off when they've talked too long, turn up the bumper music, etc. Right? So that's getting IDs 3 and 4. Monitors for stage A are IDs 5 and 6. Monitors for stage B are 7 and 8. And we have a broadcast console that is IDs 9 and 10. Cool. All right, let's throw in some racks. So once again, copy and paste is cheap. So we have a lot of SD racks in here. IDs 11 through 18 you're going to see on those SD racks. And then we have 4 mini racks and 2 nano racks. We got bored of adding stuff at this point, so we just kind of left it off there. But you'll see that we've used all 24 IDs. So each of those racks gets a separate ID. Now you'll also notice that we've connected everything here with a cable. And if I take a cable like between the broadcast console and the SD rack, you're going to see arrows on both ends of that cable. That cable is handling bi-directional communication. That means from that rack number 18 to the broadcast console, numbers IDs 9 to 10, we are getting send and return. So it can control that rack, it can hear everything from that rack or receive everything from that rack. It could send out to it if we assigned it that way in the software. Now, for those of you who have been around DiGiCo, you'll understand that there's something missing here. Now, this will all work. This entire setup, as you see it, will work. Matt Larson, why do we not want to run things this way?
Sorry, Ryan. I popped off.
That's okay. I'm just making sure you're paying attention. Why do we not want to run our setup just like we have it?
Oh, well, because if you were to lose, let's say ID number 15, the SD rack was to lose power by somebody accidentally tripping over the power, or the optics card went, you would actually lose all those other cards. The racks, I'd say 11, 12, 13, 14, plus all the mini racks. Same as if we were to lose, say, the third SD rack or desk. If that was to power down, you would lose your optical loop. So we have another cool slide that we could show, right?
It's just a quick little line. So what we always recommend is connecting the last device. It doesn't have to be ID 24, just the last device without a connection back to the first, and that is going to complete your loop. So now, if Matt's scenario of power gets lost to ID 15, if that rack loses power, somebody unplugs that cable, Mr. Forklift Driver runs over that because you didn't put it under the cable ramp because you were too busy, runs over that thing and destroys that cable, well, now that entire rest of the loop, IDs 14, 11, 12, 13, 14, 19, 20, 21, 22, 23, and 24, are all going to connect to all of the consoles the other direction in the loop. This is amazing. It's a very inexpensive way to have full redundancy in your setup. It's just that easy. Now, I think Kyle has another slide. We're actually going to show you a real life wiring diagram. So this is all using HMA connections. So this was in a large event, a conference that went on in Atlanta a few years ago. And you're going to see we have things like a monitor riser that has a console connected to it that has 4 SD racks on it. There's a front of house console out there. There's a broadcast suite, a video truck, and then an uplink connection there as well. So this is a pretty massive real-life application of this, and you're going to see that it's got all the IDs listed. It is not in any sort of numerical order, and that's okay. Opticore does not care the order it is physically connected in. So that allows you to do things back to what Dan was talking about, where we maybe want to connect our clock to the lowest ID on the network. So you don't have to physically have that lowest ID as the first in the chain. That can be wherever it needs to be for other practical purposes, such as wiring, I/O interfacing, etc. So I'll let you guys stare at this for a minute, but you're going to see there's 3 SD7s in there. Broadcast is IDs 1 and 2, monitors is 3 and 4. Front of house is 5 and 6, and those are connected in a very creative manner to the monitor riser, allowing for that loop to be established. And just pick one, like A, and just follow it. It's going to go to B on the SD rack, A out into B on the next device, A to B, A to B, A to B, A to B, all the way through that, making a beautiful loop. Can
I just jump in there actually?
Yeah, please do.
Of course, A to B, do stick by the A to B rule. But on a system like this that might get pulled apart and rebuilt night after night as you're touring a production, label everything. Make sure you connect it all the same every night. You know, the same racks, the same cables, linking the same nodes on the optical network. Because if you have a problem, you know where to go and look. You know, there's no sense of, did I plug it in there? Did I plug it in here? You know, where am I going with this? So, you know, all fine. Any order of IDs, any order of racks connected with any, you know, length of cable subject to the rules, but be consistent about how you connect it up night after night with the same cables in the same places, because ultimately it's going to make your life building a system and troubleshooting it a lot easier.
Yeah,
go ahead, Kyle.
While we're talking about this, since he's actually on the stream, or he was earlier, this was actually brought up by Louis Adamo with High Tech. He and Matt Mannix, who is with Method Production Group, who was one of the audio production managers for this event, they came up with this. And again, the big thing is, in the previous diagram we showed a loop that's, you know, device to device. In actuality, running cable like that would just take you forever. So taking 2 pieces of fiber to each location, and then you're just injecting yourself into loops. But as Dan said, make sure everything is labeled. So when you have to troubleshoot, you know what the cable equals on each end.
I will take this opportunity to tell you that we do highly recommend, you know, device to device. So something like B on a device to A on the next device, or A to B, whichever method, but pick one and stick with it. Kyle's going to show you a page in a minute under the diagnostics menu where if you follow a methodology, it's going to be a lot easier to track down issues. Hang on. Sorry about that.
Wait for cough drops.
Exactly. All right. So hopefully that's understandable there. And then we're going to continue on with the keynote as well, just showing you a little bit more in there. Now, once again, PowerPoint, copy and paste. It's really easy. But this is a way to show you, this is, I don't know what it is, but we could create it in PowerPoint, so we did. But this is somebody who obviously needed a lot more I/O than a single loop was going to provide. So we have 5 SD7s or Quantum 7s in there. We have double the amount of racks that we had before and entirety. And you're going to notice there's a red loop and there is a green loop. And that's representing one optic-core loop is red and the other optic-core loop is green. You'll notice that something like the SD Quantum 7, the first Quantum 7, that is IDs 1.01 and 1.02. That is, so from top to bottom. So that means it is ID 1 on the first loop and ID 2 on the first loop. And then since it has 2 loops, it also has ID 2.01 and 2.02. And so that means it is ID 1 and 2 on the second loop. Now, there are a whole host of other kind of best practices that you need to follow when you're doing 2 loops. And so once again, we have documentation on a lot of this. Please reach out to us. If you're getting into something this complex, we are here as a resource to be able to help you both at Group 1 in the United States, as well as DiGiCo support in the UK and your distributor. Great resources to be able to reach out to if something is at that complexity level. All right, now here is a typical setup. We have a front of house console and a monitor console. Monitor is ID 1, front of house is ID 3. The reason we're skipping 2 is that would be left for a redundant engine. So a whole nother redundant console, or it could be like in Quantum 7 that has 2 engines in it. You're going to see that we have 2 SD racks. This is IDs 11 and ID 12. So those are the first rack IDs that are available to us. We just connect them all. We have that red cable to signify closing the loop. So that is a simple loop that runs between all devices. We have redundancy between these. If the cable between monitors and front of house gets cut, disconnected, etc., we are going to get audio in that longer loop from throughout the SD racks and back to the console. All right, now let's go on to a mirrored setup. So it's going to change slightly. This is 2 Quantum 3s for front of house. So you're going to actually this time use ID 1 and ID 2. So these are the same consoles. We're going to network them together via that control Ethernet port so they can share the session between them. We're also going to have opticore looped together, and we're going to set ID 1 and 2 for the primary and redundant. You're going to see we still have SD racks, ID 11 and 12, and then we have pulled up the network tab under your master screen, under your SD or Quantum software. That's going to show you kind of how this looks. Now, unfortunately, I didn't have a console, nor did Kyle, that we didn't have two of the same console to be able to set this up for you. So it's going to look slightly different than this, but you're going to notice if you look closely that there's an A and a B. Kyle, if you can point to that, and under the B on the primary console, it says not found. So that would be like if we didn't have these two connected together via a network cable. The session wouldn't see the other console to be able to connect to. Ideally, you would have those connected with a network cable that's going to allow them to truly mirror between each other and act as a real-time, fully redundant engine. So this would be like they weren't connected because we didn't have two consoles. But anyway, so these are connected up, and you're going to see Audio Master is turned on engine A. Now, for the redundant engine, you're going to see that engine A is not found, and then engine B is connected, and it's the Audio Master. In reality, only one of those engines can be Audio Master. On something like a Quantum 7, we actually display it on one of the overview screens to let you know that the Audio Master is engine A or the Audio Master is engine B. So which engine is responsible for processing the audio and pushing that out to the SD racks or other devices that you have connected. Now, there's a little bit more to get into there. If you look down the right-hand side of that menu, I think, Kyle, you're going to go through this later, right?
Yeah, I'll go through it.
Okay, cool. Well, we won't cover that, but there's a way to send those send those sessions between engines as well as mirror, and there's actually some options to set up the method that it mirrors in. All right. So here is a Quantum 7, just showing you what that looks like on a single console. So we have two engines on this console, ID1, ID2, and then it connects to those racks, the IDs 11 and 12, to form a loop. All right, so to break this down, we set everything up in a loop, two SD racks, one console. Now, if we're using ST connectors, we're actually going to do that slightly different. Is that the next slide? Hoping it is. Fantastic. It is going to look topology-wise the same. We are still going to go from one device to the next, but you're actually going to have two individual strands when they're ST connectors. I believe we have another slide that actually goes into more detail on how this is set up. So you'll actually have the same type of thing we were just looking at. There's an SD10 with an A and a B connection. You're going to follow the same methodology as your HMA connectors. We are going to take A on the SD10 and we're going to go to B on the SD rack. And this is going to go A to B connection, and if you follow those lines, you're actually going to go A out on the SD10 to B in on the SD rack. So those are the two red lines symbolizing one cable but two strands of fiber between them. This is when you're breaking it out for ST connections. You're going to notice the green connectors that go from rack to rack, so rack ID 12 to rack ID 11. That's in to out as well, A to B. And then we're going to complete the loop using the blue cable that goes from rack ID 11 back to the SD10, in to out as well there. So the whole idea here is that out on A goes to in on B, and out on B on the same device goes back to the first device on in on that A. So we got to have a loop between the two, and we got to have a loop overall. A lot of that happens automatically with an HMA cable, but with STs you physically need to wire it that way. All right, I think I finally get to take a break. Kyle?
Yes, you do. Thank you, Ryan. That's a lot of stuff to cover in a little over an hour and a half. So, all right, next what we're going to get into is we're going to get into the curriculum that we actually use in our DiGiCo Master Series program here in the U.S. So I saw a lot of the people that have registered through Eventbrite. A lot of you guys have been in our class before. So in our class here in the U.S., we ship around between 12 and 15 desks to each city. We do carry these, and then we might do 10 to 12 cities in the fall. This year, probably going to be a little bit different, but with that, what we do is one of the most important things that we go through in class is the actual setting up of OptiCore. We're going to talk about Maddie a little bit more in this next section, but inside that class, what we want to make sure is everybody understands how to map OptiCore and where all the mapping issues actually come from. So in our classes, we set up to 5 desks that are on the OptiCore loop and a couple racks and devices, and we go step by step setting it up, and it might take us 20 minutes to do this. But the reason we do it is because we have so many users and setting it up. If somebody makes a mistake, we can point out what the mistake is. So it's by having this many devices, most of the time you're going to have 2 or maybe 3 consoles on the network. And by having this many devices, if something happens and you see a mapping error, we can actually point out what is actually happening in those cases. So, by the way, for the future, I know a lot of you guys that have come out to this training before have recorded this procedure of setting OptiCore up from the ground up with all 5 consoles. If you do have a link to that video and the quality is fairly good, make sure you send me a Dropbox link at digicoinfo@g1limited.com. So if you have one of those videos, then maybe we can produce it a little bit, clean it up, and then help share that, whether it be YouTube or on the DiGiCo Master Series Facebook page, something like that. So, all right, first thing, when we're getting into our console, first place I will always go is I'm going to go into my network settings. The reason I do that is this is one of the things that your file does not bring over. Your console will remember what its last network setting is. So if you're on tour and you're a monitor guy and your console ID is number 1, before you start loading your file and mapping OptiCore, you want to verify that that ID is still correct. So before you even start loading, go and look at your settings here. Again, 1, 3, 5, 7, and 9 are going to be your primary engines. 2, 4, 6, 8, and 10 are reserved for redundancy. Make sure before you get going that not 2 consoles are set up on ID 1. This will also create issues. Most of the time it's going to be ID 1 is going to be monitors, ID 3 will be front of house. So verify those settings. Then you're going to make sure, if you're using OptiCore, just make sure Audio Master is turned on. This also allows the console, if say our clocking priority is always the console with the lowest network ID on OptiCore. So if ID 1 is that monitors and he has to turn off for whatever reason, we want to make sure that clock still establishes and the ownership of cards and sockets on the racks still exists. So you want to make sure that Audio Master, which is in green in this picture, is selected anytime you're using OptiCore. The only time that's not true is when you're on an SD7. Again, like what Ryan was saying, is you have an A and a B engine, so IDs 1 and 2. So you're only going to have one Audio Master in that case. But in the case of just primary consoles, just everybody make sure you turn on your Audio Master. From there, the next thing I'll do before we even get into our setup for mapping OptiCore is I'm going to make sure everything is correctly connected in our system. So this is showing you a very simple setup, IDs 1 and 3, and then ID 11 on the left-hand side. So ID 11 being our rack. So you can see there where what's highlighted in red is everything is okay. If for some reason you had an error between ID 1 and ID 11, both of those would show up as ERR or error. So that is showing you where the actual loop error is occurring. So you know you need to look at that cable between ID 1 and ID 11. That is the cable that's actually bad. So as Dan said, if you've labeled your cables on each end, now you know when I go to troubleshoot, that's where I actually need to look to make sure that that cable is connected correct. The thing about this, OptiCore will map correct when you do the mapping procedure. It will map correct even if you don't have the redundant loop. But in certain situations, and Dan, you can interject if you need, but in certain situations, if you have consoles of different, maybe somebody's at 987 and somebody's on 1069 or, a newer version, sometimes when you're pushing mapping, if you don't have a redundant loop, it's not going to pass through the whole network. It may only show up one way. If you push it from one console, it might map correct. If you push from the other way, it may be completely fine. So in any case, look at this page. This is under System and then Diagnostics and your OptiCore tab. The other thing you're going to notice, let me grab on my mouse here so you can see me highlighting this. You're going to want to make sure that your loop 1 is showing 2 gigabit speed. That's your speed of the OptiCore network. And you're at 221. So that's the newest OptiCore version. If this is showing your loop is at 1 gig, you're going to be on version 220, and that's also going to create issues. The other place you also want to look is down here. We have seen in certain situations, somebody goes to grab an opticore card out of an SD rack, and if your console is showing SD rack instead of SD engine here, you're going to have issues also. And in that case, you're going to need to call support and have us walk you through, or we'll point you to the opticore reprogramming of the opticore card, so then it's then meant for an engine as opposed to a rack. So just pay attention to this. This will save you some time in the long run. If you know everything is hooked up correct from the get-go, then it's going to save some time later. The biggest thing when we talk about opticore is every device that is on the network, every console needs to have a matching devices in their list here. Thank you, Tony Luna, for this picture. This is an event we did probably 4 or 5 years ago. He was in one venue. I was in Atlanta. He was in Houston. It was the same show. But in this case, what we wanted to make sure is for every console on the network, we all have the same rack devices. If, for instance, you've got the front of house console doesn't need some of those con sends, and they take those audio ports out of their list, then you're going to have an issue when you actually go to map. Every console has to have the same devices. They don't necessarily need to be in the same order. In the case of a touring setup,
I would say they don't necessarily have to be using the racks, but they have to be defined in the session.
Correct.
Even if you have no intention of taking the audio from it or outputting to a rack, and have no channel allocation to it, they still have to be present.
Correct. Yeah. So you can choose not to use it, but it does need to exist in that audio I/O port somewhere. What I'm saying here is, in the case of a touring setup, we have multiple bands using the same control packages. It is best practice to have all bands using the same audio I/O port structure. Front of house and monitor audio structure doesn't have to match in their port orders, but all your front of house console files and all your monitor console files should have matching audio I/O structure and port order. This just prevents you having to remap every time you do a session load. Now, obviously on a one-off, you're doing a festival, bands are coming in, you're going to do your session loads, and then you're going to need to remap. But in the case of actually, if you're touring, maybe you're sitting down for rehearsals for a couple weeks, take this, your structure and then just send it to the other engineers so they can build their file, and then the audio I/O is it's already there. All they have to do is patch their in and out to those. So where we're actually going to do that, let me pull up my console screen here. So where I would go next is, if I'm on, I'm in rehearsal, what I'm going to do is I'm going to go into files, and then I'm going to go into my session structure here. So if I've already have my file established as far as my audio I/O order, which I've got something set up right here already, and maybe I want this for all the bands that are on my front of house console. So it's already established for my file, but I want to pass this on to other people. So now I can go in and just choose what sections I want to get rid of. Maybe inputs, my auxes, and my groups. I want to just get rid of those positions. And now when I save that file, I can save it. They can rebuild their input list. They can do their auxes. They can do their groups. If you need to, you can even get rid of the effects. But this is on a segment by segment basis of what is actually going on inside your console. You can clear those sections out, save it, send it to your guest bands for them to build that file. And then when all they have to do is their audio I/O structure already exists in this order. All they have to do is patch to that. So when you go to map later, you're going to map at the very beginning of your tour, save your files, and then when you load each time, there's not the complexity of having to remap because that audio I/O structure is different from band to band. The other thing that I want to show on this page is down here. It's either DigiRack default or SD-Rack default. I don't have an opticore card in this, so that's why SD-Rack default doesn't actually highlight. But in the case of these two audio I/O buttons down here, what you have to realize is when you actually get into building your file, and you need to convert it for later. Keep your MADI ports in the structure. I'm going to go back to my file here. Actually, I'll just show you on this page here. So at the very top here, you see your local I/O, then you have your rack 1, 2, and then port 3. So that is what is default for an SD9. If you are not using your MADI ports on your desk, maybe you're only using OptiCore, do not delete these ports. Leave those in there. The reason is if you need to convert your file to another console and you've deleted those ports off the original console, they will not exist when you go to that other console. So there can be issues if you try to add that port back in. There might be issues with controlling rack data, stuff like that. And so in that case, you're going to have to go back in on your new file and go into your session structure and then select SD rack default, restructure it, and that's going to rebuild your ordered default to whatever your console is. So just do yourself a favor, keep those audio I/O ports in the correct default structure for the desk.
Yeah, actually, that's because when you patch an input into a channel, the channel is referencing a port number, not an identity of a rack, or it's not saying it's an SD rack version, ID 12 or whatever. It's actually going, this is port 1, and so when you move it between consoles or need to do something to your session, you need to make sure that those port numbers remain constant and don't change.
Thank you, Dan. All right. So after we've done our network settings, then from there, I'm going to go into our audio sync. So with this, anytime you're running OptiCore, you're going to select OptiCore in every instance. In the case of running MADI, that's when we go back to the diagrams that Ryan showed about 20 minutes ago, you might select master in the case of if you are creating clock on the network for MADI. You're sending it out, maybe that SD9 is receiving its clock from the SD12 that's at monitors, for instance. So in the case of MADI, you're usually going to be selecting master or maybe MADI 1 or MADI 3 ports, MADI 1, 2, or 3. But in the case of OptiCore, always select just OptiCore. At the very top there, you'll see active sync source, so you can have a primary and a backup sync source. So if OptiCore isn't present on the network, it will automatically fall over. But anything to add there, Ryan?
No, I think that's great.
Okay. Again, look at technical note 300. This is in that Dropbox folder we sent you earlier. And it's going to go into more information regarding word clock and audio sync operation for
a lot more detail.
Yeah.
Thank you, Tony Crockett, wherever you are.
All right. We already went through this slide earlier, so just to reiterate that though, in the case of our consoles create the clock. Our racks do not. We're sending clock from the console. It's going to go through the little red box, and then in the case of the top right corner, the SD9 is receiving its clock through the little red box. So the bottom console is establishing the clock on the network. The console on the upper right is receiving its clock through the MADI Cat5 port number 1. From here, we're going to go into our audio I/O section. So first thing, again, as we said earlier, if this is showing you an SD10 and we're at 96K, so you'll see local I/O is port 1, and then ID, the number 1 in the audio I/O port section is showing rack 1, and it's default to an SD rack in this case. So you see MADI 1/2. If we're running a 48K structure, it would show port 1, port 2, which is hidden in this case because we're running at 48, or we're running at 96K in this case. So port 2 would show up, and then it goes to waves. Anything that we're dealing with on the console, say, depending on what desk you're on, it might be ports 1 through 5. You know, you've got on the Quantum 338, you've got 3 ports, technically it can be up to 6, depending on how you're running it. but usually your last port in your audio I/O list is going to be Waves or your DMI cards, depending on what desks you're on. So those are what's local to your desk. You can change those around if you need. But again, do not delete these if you are not using them, because it's just going to create issues later if you have to convert your file. About SMUX and high speed, we're not going to, for time's sake, just take a picture of this. Take your phones out. I'll give you guys a few seconds. Take a picture of this. The big thing with this is how it splits up the MADI stream between SMUX mode and high speed mode. With this, there's not a lot to get hung up on, because if you are connected a send and receive to your MADI port with a device. So if I have an MGB hooked up to my MADI 3 and I toggle high speed or SMUX, then in the software for my MGB, for instance, it's automatically going to follow that back and forth. So just know it is there. You just want to make sure each device has the same settings on each end. How this is actually split up, this is showing you it's technically channels 1 through 28 or 1 through 32, depending on if you're standard MADI or MADI 64. But how that actually works is an SMUX MADI is taking up to 64 channels, really, but it's splitting it. So channel 1A and B, 2A and B, 3A and B, so on and so forth, to get all the channels. When you go to high speed, you have to have 2 MADI cables connected. The reason is, if you're in high speed MADI and you're at 96K, you're really only seeing 48K, because it goes 1A, and then in this case, channel 29 is showing you the other part of that MADI stream. So if you've got 1 through 28, you're seeing part of that stream, but you're only seeing half of the bandwidth. So 1 through 28 at 48K, then channels 29 through 56 equals the other part of that 48K stream to equal 96K. So
if, real quick, I'll just jump in. If any of you out there have ever ran into some weird channel routing, channel layouts, things between consoles or to devices, this is usually what the culprit is. Somebody's running at 96K in a different format. You may be running at 96K or at 48K. And when you kind of run across these together, it'll be really weird. Things don't correlate. You start skipping every other channel, or you have audio showing up on 2 channels worth, things like that. It's usually a mismatch between either the sample rate or high speed and SBUX.
Yep.
And I would just add to that, actually, if you get the high speed versus SMUX wrong, third-party recording interfaces can get really upset by it. You can actually crash a certain MADI interface from another company by feeding it the wrong format of MADI. So you just really need to make sure that you understand, if you're running to a non-console product, what format of 96K it needs to be talking to.
So Dan, when you have that issue, what should they do to resolve that?
Read the manual and see what it is. I mean, most bits of kit these days will do high speed and SMUX. The only sort of big one I'm aware of is the Avid MADI interface, and it's not me picking on them. It's just their interface only does high speed, doesn't do SMUX. And if it can get confused. Similarly, actually on that front with MADI, if you feed channel 57, our control channel, at bits of kit that aren't expecting to see it, similarly they can go a little bit wonky.
And then is that just a power cycle to resolve that issue?
Remove the offending MADI stream and power cycle it, and most things recover.
Okay. As we get into OptiCore here, as I said earlier, the biggest thing that people don't really realize, we've had engineers that have been toying with their kit for quite a while, and then maybe they go to make a change where they may be changing consoles in the SD line, upgrading, and then where they've been running for 3 years and not had a single issue, they go to another desk, and then all of a sudden they can't remember exactly how they set it up originally, and then you'll see mapping errors. Usually when they send us their files, it's just because an engineer doesn't realize that he has to have everything that's on the network that the other console does. So he's like, all right, there's three racks on the network. I only need to patch from 2 of those. I'm not going to include that one. Well, you're going to get a mapping error because those devices don't actually match. So again, on front house and monitors, they don't have to be in the same audio I/O port structure, but the devices have to exist. And showing that there again, you can see on this is coming from an SD7, so we have our first 4 MADI ports. We left them in because of just the rule. It's good to just leave those in there. Port 5 is waves, and then from there we go to anything that is optical driven. You can change your ports, that's anything that's local to your desk, but if you start changing ports in the opticore section of your network, that's when you start to run into mapping errors. So this is just showing you 2 of the desks. I built the file, one on the left, Tony Luna has a better camera than I do. One on the right, that was my console in Atlanta. So I built the file, so our monitor files in different cities were exactly the same, and we had actually 3 venues, so everybody's file had to have the same port order. All right, so for this, let's go into Ryan's desk real quick. You ready, Ryan?
Yeah.
We're going to show this part live. So Ryan has a Q338 at his house. So for
Don't
this,
we all?
I only have an SD9 because that's all we could carry to the basement. First thing, when you go to add your ports, I'm usually going to select the very last port in our list. So in this case, Ryan's got a Clang DMI card in there. So you're going to select the very last port, and then from there, I'm going to go to Add Port. Then I'm going to select what the actual device type is. So I know Ryan has an SD rack, so we're going to select SD rack from the list. Next thing you'll see, it just shows that it's not connected. The reason is there's a DMI card that is going to be selected by default. In the case of if he had say like another DMI card of some sort, it would actually go to the first OptiCore ID. The reason it's going to the DMI2 is because there's not a card in that slot right now. So what he's going to do is he's going to go ahead and he's going to select OptiCore 1.24. You want to select the rack that has whatever the network ID of that rack is. Typically, from the factory, they go through all the different ports. So when you get an SD rack from the factory, it's going to show up as 1.24. Then you can change it to 1.11, which is the lowest network ID if you needed to. In this case, his rack there is 1.24. And then, Ryan, can you just point out where it says mismatch on the cards down there? So right there, it sees the rack. It shows that we're connected, but we don't have the information. So what we're going to do is we're going to go into the Conform Rack button. In just 1 second, I'm going to take your name off the screen here, Ryan, just so it's not covering up any of this. There we go. All right, so now when you hit the Conform Rack button, what that does is the Conform feature is reading something that's on the network. When you remap, that is putting those audio paths into play. Conforming is reading the path. So when he did that, it shows the rack that he has, which has looks like 7 32-bit input cards, and he's got 3 analog output cards, and then he's got an AES in the very last position there. So from here, if he needed to change and release a card to the network, he doesn't have another console in his garage, but if he needed to release one, he can go into Setup OptiCore there, touch on the card, and now that is released. So now if other desks are on the network, they could actually grab those by using the same procedure and touching on those, and then they would be able to grab them. Go ahead and remap at this point. Okay, so now everything is mapped, everything is good. He's using a single console. Ryan, I'll come back to you here in a few minutes. Before we do that, let's show him the Conform All Ports thing. So Ryan, let's go ahead and delete that port. And then hit the Conform All Ports button there. So the Conform All Ports can be very useful. This button I would use if I am building a show from the ground up. If I've never done that show before, I'm going to set up all my consoles, all my racks. I'm going to conform, and then I'm going to start building my show. Conform all ports for me as a touring engineer wasn't very helpful. The reason is usually when you have a file established and you go to bring it into a guest console, for instance, or you're going out again with the same control package and you want to make some adjustments. If you hit conform all ports, in that case, your port order may be different. So where in the case of where it says number 5 there, Ryan, can you point at the number 5 audio port? That port right there, for your file, it might be there in this case. But in another situation, when you conform all ports, it might show up in port number 7. So when you actually go to your file, all your patching is associated with, that port number 5 equals kick, snare, hat, so whatever, and so on down the line. If it's in 7, now you're going to have to redo all your patching. So the conform all ports, again, I find it very useful if you've never done the show before. You're going to set up all your equipment, conform all your ports, and then from there, then you can actually go back, you can start building your show. All right, while we're in this page right here, you can see he's spinning up some gains on some of those inputs there. And then go ahead and just hit default rack while you're there. You can see all the gains that he just dialed up are now back to 0. So from there, he's adding it back in. He's adding 48 volts back in. Go ahead and hit default rack. See, so that once, this is another way. I usually tell people to default the rack on the faceplate of the SD rack. But if you don't, once you connect to your system, if you don't want to have that gain data pulled over, then just go ahead and default all your racks so they're in a 0 state from the get-go. The single console button there, Ryan. That button right there, it can be helpful if you are the only console on the network. The issue with this button is if you have 3 or 4 consoles on the network and you push this button, it tries to grab ownership of every input and output card and saying you're a boss. So in the case of, we'll show you later how to, once you get everything set up on your network, go ahead and lock it so functions like that aren't easily accessible. Ryan, do you want to tell them the story on that one?
Yeah, we had an award show, and it was the first year they were moving the entirety of the award show over to they were moving the entirety of the award show over to DiGiCo on a single loop. So we had a couple of operators, very experienced engineers, but it was their first time on DiGiCo. I happened to be there visiting one of the systems engineers that was responsible for the setup, and yeah, just somebody decided because they needed a remap. I think they changed the input side of their console, so it actually showed up to remap inputs. And then the single console option was there as well. So this gentleman pushed that button, which of course took all the output cards away from all of the other consoles. They had actually were a day and a half, I believe, into rehearsals. Thankfully, no audio was going at this time. They were just doing camera blocking and camera placement and stuff like that. So a bunch of errors get thrown up across all the other consoles. There were 4 consoles, I believe, on the setup. And yeah, everybody freaked out there for a minute, but just reloaded sessions. Had the gentleman, thankfully, very quickly came up on the intercom and said, "Hey, I just hit the button. I think that was me." And so we were able to determine what it was. Reload sessions didn't end up being a big deal, but yeah, it can definitely make your heart race in those types of moments.
Yeah. So going into it a little bit further. So once you actually grab that rack, even before we map OptiCore for the first time. Then what I'm going to do is I'm going to go through and go to the splits and sharing section of the desk. So with this, in the Audio I/O page, you're going to go into splits and sharing. Then you're going to go into the selected rack. You can either be global full control, or I usually do it per rack. And then you're going to go into either isolate mode, receive only, or full control. Over to the right, before we talk about the isolate, receive only, and full control, you'll see on the card split section where it says split cards 4 through 11. You can turn on gain tracking, split all your cards. So that has to do also with the hierarchy of the SD rack menu, taking that input card 1 and sending it to output card 1 as an active split. 1 through 8 equals 1 through 8 on the output side. Okay, so as far as the actual permissions for the full control, receive only, so on and so forth, you'll see the SD console in isolate mode will not exchange any control data with the rack. This means that the console will neither be able to adjust rack settings, or will it, nor adjust its own settings according to returning control data. Receive only, receive only and full control is usually the majority of what people actually will use. Receive only, this just means that you are only going to be able to receive, you're only going to have trim data. The monitor guy is usually going to be controlling the preamps, and as he turns up, you only are able to see, you'll only be able to do the trim side of it. You cannot grab that preamp at all. And then full control, you're fully in control of that rack sending and receiving. On this, this doesn't have to do with optocore remapping. Anybody can go into full control mode from the optocore loop. If you have 3 desks on the loop, any of the 3 can do it. You probably don't want to do that because you're finding 3 engineers that have the same idea on what the proper gain structure is going to be made different between each engineer. But say, for instance, the monitor engineer, he's asleep in his bunk, and guitar tech comes out and he says, hey, we've got this new acoustic DI. Can we get it gained up and as a slightly different gain structure? Then at front of house, you can go into full control, grab that preamp, make the adjustment you need, and then go back into receive only. All right, we already showed you how to grab the actual card allocations from Ryan's console there, but you'll see there, if it is highlighted in like bright green, it is allocated to the console and can be changed. That's how he was able to release it. Once you remap optocore though, then it's going to show grayed out. It's that slightly grayed out green check mark. That means that he has control of it. Then he's going to have to go back in after he's remapped and release it so anybody can grab it. So green means you have control of the card. Red X means it is allocated and anybody else on the network can grab it. Okay, once you do that, then you're able to remap per desk and remap optocore, and now any changes you've made are instantiated on the network. So once we get past this, let's see. If there are no errors, then you're good to go, and then you can start adding your con, send, and receives. We always will tell people to delete your con, send, and receives, get your racks up and going, make sure those are green before you go on. The reason is, we'll show you in the optocore details section in just a minute, but that's usually where a lot of the optocore errors come from, have to do with the con, send, and receive section. So you want to make sure your racks are good. If your racks are not good, what you want to, if you are receiving an optocore mapping error, it might have to do with allocation of who is trying to grab a card slot. So for instance, if I'm using a file from the fall of that year and my other engineer is using one from the summer of that year, and maybe at one time we're both trying to grab the same output slot, the optocore is going to say, hey, you know, you're trying to map, both of you are trying to grab control of one of those output cards, and you're going to get an error. So at this point, then what you need to do is look at that optocore details tab and then investigate who is creating the error on the loop. So in this case, maybe we've got 3 different consoles, IDs 1, 3, and 5, and we go to do a concert where ID 5 isn't there. The broadcast console isn't there. he usually has output cards 6 and 7 on the network. If I want to get, if I want to be able to grab those, I cannot grab it in my file because the broadcast console in his file had it. So it's allocated to broadcast console ID 5. He doesn't exist on the network. So from there, what I need to do is, easiest way to release this is to actually go back into the OptiCore details tab and then select one of these three things: clear all outputs, broadcast all output IDs, or broadcast only my output IDs. Most of the time, if you clear all output IDs or clear all outputs, what that's going to do is any output that's on the network that's a card allocation, it's going to release it, and then everybody manually has to go grab it. If it's already built in your file, you can fire a snapshot that could bring that patching back. What we usually recommend is the green, broadcast only my output IDs. Usually the monitor guy is going to have the most outputs on the network. So what that's going to do is the monitor guy is going to push that button, and then what that's going to do is it's going to map everything to the monitor console who has the outputs, and then every other console on the network is then going to be able to go grab their original card slots. But it just gets rid of any issues that there may be in the actual mapping process. Again, the rack part is usually the easy part when you go to map. You map once and it's usually good. If there is an error, I would say 9 times out of 10 go to look at this. Dan or Ryan, anything to add on anything that you guys have experienced?
I actually just stepped away for 2 minutes to grab a drink because it's late here, so I'm afraid I missed that.
He has been riveted going through all the. I'm just kidding. So no, actually, Kyle, I think you covered it well as far as what needs to be covered in that area. OptiCore is one of those things that once you come up with a kind of a workflow and how you should treat it, it's generally going to work the same for you every day. And like Kyle's saying, until you make a change, and then you kind of have to know what change you're dealing with, how you want to approach it. Best is, as Kyle mentioned many times, communicate between front of house monitors, whoever else is there. Make sure everybody's aware of the change, and even if they don't care about it, don't want to see it, make sure you're all communicating with how that's happening, because it is a network. They do all need to talk to each other, whatever the changes you are making, as long as it resides on OptiCore.
Thank you, Ryan. The other thing about this, when we go to remap, it doesn't really matter. Any person on the network can remap. Just have one person that's in charge. When everybody just starts hitting remap all OptiCore, it can slow things down. So have somebody in charge, be on your radios, be on ClearComm, pay attention to that. Okay, so once your racks are up and good and you're green, then this is where we're going to go into adding our con, send, and receives. Somebody told me a while ago, I think it was, it may have been Titus, who's our CTO here in the US for DiGiCo in Group 1, but he says, think of it as the OptiCore devices are existing on 2 different layers. So your rack devices are always going to exist on layer 1. So in your file, you're looking at a rack ID 1.11 through 1.24, or in the case of a dual loop, 2.11 through 2.24. And so your file is looking for that rack on whatever rack device ID it is. When you get into doing your con, send, and receives, these have to do with your console, but it's actually looking at another layer down. So it's looking for ID 1, and then underneath that, you've got underneath ID 1, let me see if I can get my mouse over here. Okay. It's actually looking for this serial number. So in your file, your OptiCore is remembering this serial number. So this is why when you go from, you're on SD12s on tour with your preferred vendor, you go to do a one-off and you go to map right away and you're getting OptiCore mapping errors. It's because your con, send, and receives, which has to do with your network ID, that's where the mapping errors will always occur. So delete the con, send, and receive ports. Then when you add those back in, now this serial number that's right here, it's going to be current to what the current console you're on. And so then when you add your content and receives back, then that's going to get rid of some of those mapping errors there.
I would say just on that note of adding console send and receive port, I always find that if one person adds a send port, everyone else conforms and picks that up as a receive port, you remap, everything's good. If someone else then needs another console send receive pair, the second console will generate the send port that they need with the number of cards in it. Everyone else then conforms, they get picked up as receive ports, and you do it. You don't try and everybody add all their console sends and receives all at the same time, because inevitably it's probably not going to work. You need a bit of a logical sort of step through process in putting it together.
Yeah, and this is one of the things inside of our class. We do this with 5 consoles. Everybody does consent and receives. And we do it a couple different ways. We usually show them each console as their consent, as Dan said. Everybody conforms. The reason is you're always going to have, out of those 5 consoles, one person that's not paying attention. And that one person, by not conforming their rack, when you remap OptiCore, you're going to go, okay, which one of you is not the same? And it will actually put up in the error that pops up where you actually need to look. And you're like, all right, ID 105. You didn't add that. You didn't conform that rack. You were not expecting that. That's where it comes from. So we, in class, and if we can, if somebody sends me a video, we can actually show this. The reason we do it that way is because we want to get it through people's heads that if things don't match, that's usually where you're going to find an error.
Yeah, ultimately what you're doing is, you think of a highway with lots of lanes in. You're allocating audio to these individual lanes of the highway, this audio highway that connects everything together. So if lots of people try and do it all simultaneously, inevitably these things are going to clash, or the exits and entrances off this audio highway just don't do what you expect them to do. So good advice there from Carl. Just take your time, do it one at a time, and make sure everyone's paying attention.
Yeah. So once in class, once we show everybody, we conform each consent and receive. So we have one person put a consent on the network, everybody conforms, we remap. We go on to the next one, because each step down the line, it's showing we'll remap 5 times to make sure that everything is correct. Now that everybody understands everything needs to match, because usually you're going to run into 1 or 2 people that are not paying attention, and we'll get those errors, then everybody kind of gets on the same page. So once we get to that point, then what we'll do is I'll usually have them actually delete all the ports all the way through their racks, because the racks are good to go. Then say, everybody, add your consens on the network. So everybody put your consens on the network, give me a thumbs up, okay, everybody is good. Now, everybody conform all ports. And then when you do that, you have 5 consoles that put a consent on the network, you conform all ports, and then it's going to bring those con receives from the other 4 desks onto your network, then you can remap once. So the big thing about it, most of the time, you're going to be 2 consoles. So add your consent to the network. You're going to conform your rack, so you see that device. Then add your consent from the opposite desk, conform rack, and you're good to go. All right, the last thing after that, Ryan, let's go back to you. Can you show us on your desk the lock OptiCore feature?
Sure.
Okay, now if he goes back into cards and sockets, notice single console is gone. Notice
You're
going to
set up OptiCore is what you're asking for.
Yeah, OptiCore details.
Mm-hmm.
See those, just unlock it and then show that page right there. See those things that are highlighting and going away? If every console locks their network, everybody has to unlock in order to make a change. So once everything is established on the network, lock your OptiCore loop so no changes can actually be made.
The only exception to that rule, actually, is that if you are changing, I believe, which inputs you are pulling from a rack, which has no bearing on anybody else, I think you might be able to change that. But it's certainly in terms of channel allocation within the OptiCore loop and output card allocation, lock OptiCore is your safety blanket.
Yep. Okay, last thing we're going to go into, that's the part of the OptiCore demo. What we're going to show you is a couple other things in the Audio I/O section. So what I'm going to do is I'm going to go back over here to my SD9 that's in front of me, and we're going to go through this virtual rack that is not actually connected inside my system. First thing up here, we can add our name. So in this case, I'm calling my virtual rack. You could call it whatever you want. Your stage left rack, your stage right rack, whatever that might be. Because this doesn't actually exist on the network, if I needed to change a card slot, I can go here and select whatever the card type is inside that rack. This is also if you're using the offline editor, if you want to build up a system, this is where you're actually going to go. You're going to select each card slot and do the drop down to build your virtual rack inside the offline editor. While we're in here, let me get rid of this floating layer button here. While we're in here, we can go in and name each socket individually. So for instance, if I had 16 wireless mics starting on channel 25 here, I could go to my group name and say, let's say RF section 1. We'll go to this card slot. We'll say RF section 2. And then here, I'm going to go into our socket name, and I'm going to say RF. We'll say 16 channels. And then I'm going to select auto name. So you'll see right now, channel 25 is RF, just RF. Now if I hit auto name, now you can see the next 16 channels on my list are automatically named 1 through 16. Now if I needed to actually go patch, I can go into my menu here and go into my virtual rack. I'm going to go into RF section 1, and you'll see it's right now that channel is called channel 42. At the very bottom of that highlighted channel is channel 42. So now if I patch to it, you'll see it brings the name over. So in any case, you can label things inside your rack first and then do your patching. And as long as the channel list name is a default name, it's going to pull the name over from the actual socket itself. While we're inside here, what we can also do is we can go into what's called line check mode. So what line check mode is good for is instead of going through a normal line check on a channel by channel basis on your surface, what you can do is you can go inside here, select a socket, hit listen. You can select 48 volts if you need to on a channel. You can grab the gain if you need to for that channel. And when you do this, you are listening at the preamp level. So if you're going into an insert or you've got a high pass filter or you have a gate, this is before any of that channel processing happens. So you're listening at the actual preamp itself. So it makes it really easy. You can just select on the screen channel 4, channel 5, so on and so forth, and you're listening at the preamp. And so again, under cards and sockets, the line check mode right here. The listen is going to go to either your solo 1 or solo 2 buses. All right. Anything else I need to cover in here? We've touched on the majority of this.
You're about to go into the next section. I think that's all we really need to cover in there. Yeah, I think you got it.
All right. So last thing, we're not going to really go over virtual sound check and the hardware needed. But if we needed to take this rack and send it channels like, say we're at 48K, we could send 56 channels of MADI to one of our other 2 sources. So in this case, I could send it to my MGB port. And by doing that, that's taking channels 1 through 56 and sending it directly to the MGB, a 1-for-1 copy off of the preamp. No channel processing, anything like that. It's the preamp only. That raw audio data is being copied from the audio port number 5 to audio port number 3. Now, when we need to do playback virtual sound check, we just hit listen to copied audio, and now we're listening back for the MGB coming back into the system. There's no other patching that is needed. And the other cool thing about that, it is, in the case of if we have preamps, let's see if I have one on channel 1 here, you have a listen safe function also. So I call that our karaoke button. So maybe you had a rehearsal, band came in, the vocalist didn't want to come in. Now when you go and play back your source, now say channel 1 is their vocal. Now they can actually do a combination of the virtual playback along with the live vocal or whatever's listen safe. And you can do that on the channel by channel basis. Last thing, I'm going to unassign that so it's available. Patching to that port is available inside of our copy audio router. But when we go into our copy audio router here, now this is anything that exists on our network. Say if I've got OptiCore and I've got all my consent and receives and my racks, I can take any of those paths and put them on the network for the other desks to actually grab. So in this, I've got my virtual rack, and if I wanted to patch that directly to my MGB, now I can scramble patch. So maybe I want these first channels, then I'm going to skip. I don't need channels 12 through 16. I'm going to start down here. I can double patch sources. So I find the copy audio router a lot more flexible in being able to pick and choose where I'm going to send things. In the case of if you think of you run out of room on your SD rack, your inputs and outputs are totally used up. But maybe you need to send 3 more outputs to monitor console. So what you can do is, if you have your consends, take your program feed or whatever you're needing to send back there, take those as a direct output from that aux or group or matrix, put it on the consend, and then at the monitor console, maybe he's not using any of his local outputs on the back of his desk. So what he can do is he can grab some of the sources and take them directly to his local I/O on the back of his desk. So it just frees up, you having to rent a whole nother rack in order to get a couple more outputs or inputs out of the system. So this is a completely flexible router, input or output wise. If I de-expand this, you'll see the set listen source button that I'm toggling up here. If I now want to listen, red are the primary paths. That's what I'm listening to if I hit listen to copied audio up here. But if I need to, I can toggle these from yellow to red. Now the red is what I'm listening to as opposed to the yellow path on the network. So, all right. I think that is it, what we were trying to cover for today.
Awesome job, Kyle. Thank you for covering that.
All right. Let me go back to our screen here.
All right, well, thank you, Kyle, for taking us through that. Let's jump into some Q&A time. Does that sound good?
Yeah.
All right, Dan, did anybody give you any good questions?
Actually, I think we've managed to pretty much cover most of them as
Awesome.
we've gone. I would say that if there's anything we've missed, I think at the bottom there will be a website address that appears at the bottom. Do feel free to send your questions there. And if we have missed out, apologies, and we will come back to you individually to try and answer them. But I think between Matt Larson and I we've managed to probably cover most of the things.
Fantastic. Well, let me just say from all of us here, thank you so much for joining us. You're definitely a special breed who will sit through a 2.5-hour webinar on digital audio protocols. So thank you. Appreciate you spending your time with us. If you want to see any other videos from us, if there's anything specific you want us to take a deep dive into, any more webinars or videos along these sorts, let us know. Put out, email us, throw it out in the comments, whatever is easier for you. Anything you want to see in depth, let us know. We're here to give you hopefully the information you need and want. Thanks for staying with us today. Thanks for joining us. Kyle, I believe this one is going to be posted later. Is that correct, Dan? You may know that as well.
It is. It will go up on YouTube and it will be available. I'll probably put it on Facebook as well. And we should probably, Kyle, I think we've got a slide maybe with a graphic for what's coming up later this week.
Yes.
Is this the new Epic one that's going to be on Friday?
So, yeah. So Friday night or
Can't
Friday
miss
afternoon
this
for you
one.
guys, there is something really, really not to be missed. Our leader, James Gordon, and our technical director, John Stadius, who we don't let out in public particularly often. There's a very good reason for that, I think, actually. But we have the pair of them, as a sort of meet your maker, ask us anything questions on Friday night. So that really is going to be something totally special. You've got a couple of days to think up some tricky questions for them. I am very much looking forward to that. I think Ryan and myself will be here with James and John on Friday night. On Saturday, we have episode 2 of Matt Napier. Matt Napier is monitor engineer for Madonna and Roger Waters, and he has done a part 2 on an SD12 of how he sets his console up. It's I watched it this week. It is fantastic. So Saturday night, if you've got nothing better to do, there's nothing on the TV, I suggest you tune into that as well. So we have some good things coming up, and then
both of those, to be clear, are on Facebook. So they'll be on the DiGiCo Facebook page.
DiGiCo Facebook Live, yes.
Yes.
No invite required.
No invite required. Do tune in. Do think up some questions for James and John, because I think we should put them on the spot and
absolutely
have some fun with them on a Friday night.
All right. So before we go,
plenty to look forward to.
Before we go, what I'm going to do is I'm going to keep the stream open for another couple minutes. I'm going to go back to that QR code so everybody has a chance to take a picture of it. Again, when we actually publish this to the public, we're going to take that Dropbox link and put it in there. Take that Dropbox link, save it to your desktop, put it in a Word document. That way, if you click on that link, it will be updated. So if I make an adjustment 2 weeks down the road, you'll have those adjustments. Remember, inside that Dropbox folder, you're going to have the quick start guides are probably the Cliff Notes versions of this. This presentation that we did, as far as the PDF version, it will be inside there. So if you need to cross-reference some of those diagrams, it will be in there. So, all right. Thanks again, everybody. And
really appreciate your time. Thank you, Matt. Thank you, Kyle. Thank you, Dan. Everybody for joining us today. We appreciate you, and we'll see you soon. Thanks.
All right. Thanks, everybody.
Thank you, Ryan.